champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. Let's start this session here. In this session, we are going to solve the paper for JEE Mains 29th June shift. So let's begin. The first question is, let alpha be a root of the equation 1 plus x square plus x to the power 4 is equal to 0. Then the value of alpha power 1011 plus alpha power 2022 minus alpha power 3033 is equal to. So in this question, an equation is given. Let us first write the equation. The equation is 1 plus x square plus x to the power 4 is equal to 0. And it is given that alpha is a root of this equation. Okay. So the first thing that we have to do is we have to find the factors for this equation. Okay. So if we factorize this equation, we get two factors, that is x square plus x plus 1. And the second factor is x square minus x plus 1. Okay. There is a short trick to check these factors. When we multiply both these factors, then we get the equation back. Okay. So let us multiply it and check it. X square into x square is x to the power 4. X square into minus x is minus x cube. X square into 1 is x square. Plus x into x square is x cube. X into minus x is minus x square. And x into 1 is x. Then 1 into x square is x square. Right? Then 1 into minus x is minus x and 1 into 1 is plus 1. Now you can see that minus x cube and plus x cube will be cancelled. Plus x square and minus x square will be cancelled. Plus x and minus x will be cancelled. So what are the remaining terms? Remaining terms are x to the power 4 plus x square plus 1 is equal to 0, which is the given equation, right? So two factors are x square plus x plus 1 and x square minus x plus 1. Okay. If we talk about the first factor, which is x square plus x plus 1 is equal to 0. Okay. Then for this factor, we have two different roots. The roots will be omega and omega square. Okay. Since all the terms are positive, so the roots will be also positive. So we can say that omega and omega square are the roots of x square plus x plus 1. When we talk about the second factor is x square minus x plus 1. Then for this factor, the roots will be minus omega and minus omega square. All right. So we can say that minus omega and minus omega square are the roots of x square minus x plus 1. All right. So total we have four roots. Okay. What are the four roots? Omega, omega square, minus omega and minus omega square, right? These are the four roots. Now in the question it is given that alpha is a root of the equation. Okay, means alpha is also the root of the equation. It means that alpha will be equal to one of the values, right? Alpha will be equal to one of the given four values. So let alpha be equal to first value, which is omega, right? So we are supposing alpha is equals to omega. Now let us look at the value that we have to find. This is the value that we have to find. All right. So let us write it. The value is alpha power 1011 plus alpha power 2022 minus alpha power 3033. Okay. If alpha is equal to omega, it means we have to substitute the values. Okay. So this becomes omega power 1011 plus omega power 2022 minus omega power 3033. Okay. Since we have assumed that alpha is equal to omega. Okay. So now listen very carefully. Okay. We have alpha is equal to omega. Okay. Omega power 1011. Omega power 1011 can be written as omega cube power 337. Okay. Why we are changing it in the form of omega cube? Because we know that omega cube is the cube root of unity. Okay. Do you know what is the value of omega cube? The value of omega cube is 1. Okay. Since this value is 1, so 1 power anything gives 1. That is why, just to simplify this expression, we are changing it into the form of omega cube. Okay. So omega power 1011 can be written as omega cube power 337, right? Because 3 into 337 gives 1011. Similarly, omega power 2022 can be written as omega cube whole power 674 minus Omega power 3033 can be written as omega cube power 1011. You can check it. 3 into 337 is 1011. 3 into 674 is 2022. Okay. And 3 into 1011 is 3033. Okay. So now we have this values. Now let us put the value of omega cube. We know that omega cube is equal to 1. So it will be 1 power 337 plus 1 power 674 minus 1 power 1011. All right. So 1 power 337 will be 1 plus 1 power 674 will be 1 minus 1 power 1011 will be also 1. But since there is a negative sign, so it will be minus 1, right? So this plus 1 and minus 1 will be cancelled. So the remaining term is 1. So the required value of the given expression is 1. I hope you are clear with this question. And if we look at the options, the correct option here is option A, that is 1. Okay. Next question is, let argument of z represent the principal argument of the complex number z, then mod of z is equal to 3 and argument of z minus 1 minus argument of z plus 1 is equal to pi by 4 intersect. In this question, it is given that argument of z is principal argument of complex number. All right. And we have to find at how many points both these given equations or expressions intersects. Okay. So let us write the given terms first. It is given that mod of z is equal to 3 and argument of z minus 1 minus argument of z plus 1 is equal to pi by 4. If we look carefully, the first expression is equation of circle. It represents an equation of circle, right? And the second expression, it basically represents an arc. All right. And the second equation can be also written as argument of z minus 1 upon z plus 1 is equal to pi by 4. Because argument of z minus 1 upon z plus 1 will be equal to argument of z minus 1 minus argument of z plus 1. All right. Now, the first expression is mod of z is equal to 3. It represents equation of circle, right? Since it represents equation of circle, then center will be 0, 0 and the radius will be 3. All right. So first let us understand the basic diagram related to this question. Firstly, we have to draw a coordinate axis, right? Then first equation is the equation of circle. So let us draw a circle first. This is the circle for mod of z is equal to 3. All right. This circle have the radius 3 and this is the origin. So this point will be 0, 3 and for x is the point will be 3, 0, right? Now second part represents an arc. So let us draw an arc. Consider this as the arc. This is the arc for argument of z minus 1 upon z plus 1 is equal to pi by 4. All right. Now, we have to find that at how many points this both curves will intersect each other. Okay. So for that, we need to find the coordinates, radius and center of the given arc. Okay. So listen very carefully. If we talk about the complex number z, what is the complex number z? Z is denoted as x plus iy. Okay. So if in respect to this z, if we talk about argument of z minus 1, this will be equals to tan inverse of y upon x minus 1. Okay. And if we talk about argument of z plus 1, then with respect to the complex number that is x plus iy, argument of z plus 1 will be equals to tan inverse of y upon x plus 1. All right. And we have an expression which is argument of z minus 1 minus argument of z plus 1 is equal to pi by 4. So now let us put both these values in this given expression, right? So it will be tan inverse y upon x minus 1 minus tan inverse y upon x plus 1. It is equal to pi by 4. For this part, you have to remember this basic concept that if the complex number z is equals to x plus iy, then argument of z minus 1 will be equal to tan inverse y upon x minus 1, and argument of z plus 1 will be equal to tan inverse y upon x plus 1. Okay. So this is the basics that you have to remember. Now, you can see that we have tan inverse y upon x minus 1 minus tan inverse y upon x plus 1 is equal to pi by 4. Okay. So here we have to use a formula. And the formula is tan inverse x minus tan inverse y. Do you know what is the formula for tan inverse x minus tan inverse y? It is equals to tan inverse x minus y upon 1 plus xy. Okay. So we have to use this formula here. The value of x is y upon x minus 1 and the value of y is y upon x plus 1. So this will be tan inverse x minus y. What is x? Y upon x minus 1 minus y. What is y? Y upon x plus 1. Divided by 1 plus x into y. X into y means y upon x minus 1 into y upon x plus 1. And this will be equals to pi by 4. All right. Now further simplifying this will be tan inverse. In the numerator part, if we take the LCM, it will be x minus 1 into x plus 1. What is x minus 1 into x plus 1? It will be in the form of a minus b and a plus b. So a minus b into a plus b is a square minus b square. So x square minus 1 square. So the LCM will be x square minus 1. 1 square is 1. All right. Now, y will be multiplied with x plus 1. Okay, this y will be multiplied with x plus 1. So it will be yx plus y minus this y will be multiplied with x minus 1. So it will be minus of yx and plus of y. Minus minus will be plus. Now talking about the denominator part. Here also we have to take the LCM, but first let us multiply both these numbers. So it will be 1 plus y square upon x minus 1 into x plus 1. All right. So this is equal to pi by 4. Again, simplifying these terms, tan inverse yx and minus yx will be cancelled. Y plus y is 2y divided by x square minus 1 divided by 1 plus y square into 1 divided by x minus 1 into x plus 1. Okay, so here we have to take the LCM. Again, the LCM will be x minus 1 into x plus 1, which is in the form of a minus b and a plus b. And we know that a minus b and a plus b is equal to a square minus b square. Okay, so it will be x square minus 1 square. So the LCM will be x square minus 1. Okay, now here we get x square minus 1 plus y square, right? Now you can see that x square minus 1 and x square minus 1 is common, so it will be cancelled. So this is equal to pi by 4. So the remaining terms are tan inverse 2y divided by x square minus 1 plus y square is equal to pi by 4. Okay. Now, to remove this tan inverse, let us take tan on both the sides. Okay. So when we take tan on both the sides, it will be tan of tan inverse 2y upon x square minus 1 plus y square is equal to tan pi by 4. Do you know what is the value of 10 pi by 4? 10 pi by 4 is equal to 1. Okay, this tan and tan inverse will be cancelled. So the remaining terms on the left hand side will be 2y upon x square minus 1 plus y square is equal to 10 pi by 4. What is 10 pi by 4? It is 1. All right. So 2y will be equal to x square minus 1 plus y square when we cross multiply this. So we have an equation x square minus 1 plus y square minus 2y is equal to 0. You can see that this is the equation that represents a circle. Okay. And this is the equation that we have obtained from the expression that was representing an arc. Okay. So from this equation, we can say that we obtain the center point. The center point for this equation of circle will be 0, 1. Okay. What is the center? Center is minus g, minus f. All right. And the radius here will be root 2. All right. So now we have the radius and the center for the arc. Okay, the arc is for the argument of z minus 1 upon z plus 1 is equal to pi by 4. So we have the center. Okay, the center will be 0, 1. And what will be its radius? Its radius will be root 2. All right. So these points will be minus 1 and plus 1. But Since the center of this circle is 0, 1 and the radius is root 2. So you can see that both these circles will not intersect each other at any given point. Okay. It is very clear from the diagram that both the circles will not intersect each other at any point. Okay. So we can say that both this curve intersect each other at 0 points. Okay. So according to all the options, the correct option will be option C, which is nowhere. Okay, it means that it will not intersect anywhere. So the correct option is option C here. Next question is, let A is equal to 2, -1, 0 and 2. If B is equal to I minus 5C1 adjoint of A plus 5C2 adjoint of A square minus so on up to minus 5C5 adjoint of A power 5, then the sum of all the elements of the matrix B is. We have to find the sum of all the elements of the matrix B. And you can see that B is equal to this expression. Now let us understand this expression. It is starting with I. I is a identity matrix, right? But you can see that the other elements in B are in the form of expansion. It is starting with 5C1, 5C2 and up to 5C5. And also with that, there is a interchange of sign, which is negative sign, then positive sign, then negative sign, then positive sign, and then negative sign. All right. So here this I is not in the form of numbers. Okay. Because this whole expression is in the form of expansion. So basically B is the expansion of I minus adjoint of A power 5. Okay. And here I is not in the form of numbers. So we can write I as 5C0 into adjoint of A power 0, right? Because this is the first term. Second term is 5C1 into adjoint of A power 1. Next term is 5C2 into adjoint of A power 2. And it is going up to 5C5 into adjoint of A power 5. All right. So firstly, we need adjoint of A. Okay. So what is matrix A? Matrix A is 2, -1, 0 and 2. This is a 2 cross 2 matrix. 2 cross 2 matrix means there are 2 rows and 2 columns. So how do we find its adjoint? It is very simple. We have to swap both these values and we have to interchange the signs of this both terms. So adjoint of A will be 2, 1, 0 and 2. Okay. Now let us find I minus adjoint of A. Okay. Because to find B, it is the expansion of I minus adjoint of A power 5, right? So let us expand this whole term. So B will be equal to I. What is I? I is 5C0 into adjoint of A power 0. Then with a negative sign, 5C1 into adjoint of A power 1, right? Then with a positive sign, 5C2 into adjoint of A power 2. Then with a negative sign, 5C3 into adjoint of A power 3. Then with a positive sign, 5C4 into adjoint of A power 4. And at last with a negative sign, 5C5 into adjoint of A power 5. So this is the basic expansion, right? It is same, only in the place of I, we have written 5C0 into adjoint of A power 0, just because it is in the form of a expansion, right? So we can write B as I minus adjoint of A power 5. Okay, it means that B is the expansion of I minus adjoint of A to the power 5. So to calculate I minus adjoint of A to the power 5, we first need the value of I minus adjoint of A, right? What is I? I is an identity matrix. So I minus adjoint of A will be 1, 0, 0, 1 minus adjoint of A. What is adjoint of A? 2, 1, 0 and 2. When we subtract this, first element will be subtracted with first element. All right. So 1 minus 2 is -1. 0 minus 1 is again -1. 0 minus 0 is 0. And 1 minus 2 is again -1. So the value of I minus adjoint of A is -1, -1, 0 and -1, right? Now let us calculate I minus adjoint of A square. Its square means -1, 0, -1, -1 into -1, 0, -1, -1, right? Because this is the value of I minus adjoint of A. If we want the square, it will be multiplied 2 times, right? Now, do you know how to find the product of two matrices, it is very simple. We have to multiply first row with first column, then first row with second column. Similarly, second row with first column and second row with second column. All right. So when we multiply first row with first column, -1 into -1 is 1, plus -1 into 0 is 0. Then multiplying first row with second column, -1 into -1 is +1, and -1 into -1 is again +1, right? Then multiplying second row with first column, 0 into -1 is 0, and -1 into 0 is again 0. Multiplying the second row with second column, right? So 0 into -1 is 0, -1 into -1 is +1. Okay, so its value will be 1 plus 0 is 1. Then 1 plus 1 is 2. 0 plus 0 is 0. 0 plus 1 is 1. So the value of I minus adjoint of A square is 1, 2, 0 and 1. All right. We want I minus adjoint of A power 4 also, because at last what we want I minus adjoint of A power 5. Okay. So let us calculate I minus adjoint of A power 4. Its value will be equals to what? We have the value of I minus adjoint of A square. So I minus adjoint of A power 4 will be I minus adjoint of A square multiplied by I minus adjoint of A square, right? It is equal to I minus adjoint of A to the power 4, right? So let us find its value. Here you can see that base are same. So power is added. That is why it is equal to I minus adjoint of A to the power 4. Okay. We have this value I minus adjoint of A square. It is 1, 0, 2 and 1. Again multiplied with 1, 0, 2 and 1. Now performing the same method, that is multiplying first row with first column, then first row with second column, and similarly second row with first column and second row with second column. So its product will be 1 into 1 is 1, 2 into 0 is 0, then 1 into 2 is 2, 1 into 2 is again 2, right? Then 0 into 1 is 0, 1 into 0 is 0, 0 into 2 is 0, and 1 into 1 is 1. So its value will be 1 plus 0 is 1, 2 plus 2 is 4, 0 plus 0 is 0, and 0 plus 1 is 1. So value of I minus adjoint of A to the power 4 is 1, 4, 0 and 1, right? Now what we have to find at last, we have to find the value of I minus adjoint of A to the power 5, okay? So what is I minus adjoint of A to the power 5? I minus adjoint of A to the power 5 will be equal to I minus adjoint of A to the power 4 into I minus adjoint of A, right? Here also base is same. So finally it will be what? I minus adjoint of A to the power 4 plus 1, which is the power. Here the power is 1 and here the power is 4, right? So 4 plus 1 is ultimately 5. So its value is equal to I minus adjoint of A to the power 4 into I minus adjoint of A. Okay. So what is the value of I minus adjoint of A to the power 4? It is 1, 4, 0 and 1. Multiplied by what is the value of I minus adjoint of A? Let us see. I minus adjoint of A is equal to -1, -1, 0 and -1. Okay. So putting this value -1, -1, 0 and -1. Again, now we have to find the product of both these matrices. So multiplying first row with first column, it is 1 into -1, -1, plus 4 into 0 is 0. Then multiplying first row with second column, 1 into -1 is -1, 4 into -1 is -4. Multiplying second row with first column, 0 into -1 is 0, 1 into 0 is 0. Then at last multiplying the second row with second column, 0 into -1 is 0 and 1 into -1 is -1. So it will be -1, -5, 0 and -1. This is the value of I minus adjoint of A to the power 4. Okay. And we know that B is equal to I minus adjoint of A to the power 5, right? It is the value of I minus adjoint of A to the power 5, right? So what we have to do is we have to just substitute this value. It means that B is equal to -1, 0, -5 and -1, right? Because we have already seen that B is actually the expansion of I minus adjoint of A to the power 5, right? So we have the value. So we have substituted this value. So B is equal to -1, -5, 0 and -1. Okay. So what we understand is by finding the value of this expansion, we find the matrix B. Okay, there are 4 elements in matrix B. What are the elements? -1, -5, 0, and -1. We have to find the sum of all the elements of B. So let us find the sum of all the elements. Sum of elements of B will be -1 plus -5 plus 0 plus -1. All right. -1 minus 5 is -6. -6 minus 1 is -7. So sum of all the elements of B is -7. All right. These are the 4 elements of B, which is -1, -5, 0, and -1. Their sum is equal to -7. So for this question, the correct answer is -7. I hope you are clear with this question. In this question, we have used the basic concept of matrix and finding the product of two matrices, right? And we have also seen how to find the adjoint of a 2 cross 2 matrix, right? And we have learned how to expand a value. So I hope you are clear with this question. It was a very, very simple question. And the correct option for this question is option C. Next question is the sum of the infinite series 1 plus 5 by 6 plus 12 by 6 square plus 22 by 6 cube plus 35 by 6 to the power 4 plus 51 by 6 power 5 plus 70 by 6 power 6 plus so on is equal to. This series is an infinite series, right? We have to find the sum of this series. So first let us understand what is the pattern of this series, okay, or how this series is made, okay? So if we look at the denominator, we have the same numbers, which is 6, and the power of 6 is increasing. Okay, if we leave this one and we focus on the remaining part, then we have denominator as 6 and the power is increasing. All right. Now, if we look at the numerator, okay, we have a AP formed here. Okay, how AP is formed? You can see that first two numbers are 5 and 12. 12 minus 5 is 7. Then next two numbers are 12 and 22. 22 minus 12 is 10. Next two numbers are 22 and 35. 35 minus 22 is 13. So you can see that it is forming an AP. Okay. What is AP? AP is a series which have the common difference same. You can see that 10 minus 7 is also 3. 13 minus 10 is also 3. Okay. So this numerator is basically forming an AP, right? So for this type of question, what we have to do is we have to apply a different methodology. So let us understand that. The first thing that we have to do is let this given series be equal to S. So S will be equal to 1 plus 5 by 6 plus 12 by 6 square plus 22 by 6 cube plus 35 by 6 power 4 plus 51 by 6 power 5 plus 70 by 6 power 6 and so on, right? Now, next step that we have to follow is we just have to divide both the left hand side and right hand side by 6. Okay, why by 6? Because we divide both the sides with the number that has the increasing power. And we know that 6 is the number that has the increasing power. Okay, the power of 6 is increasing. So what we have to do is we have to divide both the sides with 6. So left hand side will be S by 6. Right hand side will be 1 by 6 plus 5 by 6 square plus 12 by 6 cube plus 22 by 6 power 4 plus 35 by 6 power 5 and so on, right? Now consider this as equation 1 and consider this as equation 2, okay? Now there is a very simple step that we have to perform 1 minus 2. It means that we have to subtract second equation from first equation, okay? So S minus S by 6 is equal to, see, this 1 is a different number, okay? Except 1, all the terms are in the fraction. So we write 1 as it is, okay? Then what we do is the fractions that have the same denominator, we subtract them. For example, 5 by 6 minus 1 by 6. So it is 4 by 6, right? Then next is 12 by 6 square minus 5 by 6 square. So it will be 7 by 6 square, right? Then 22 by 6 cube minus 12 by 6 cube. So it will be 10 divided by 6 cube, right? And so on. All right. I hope this step is clear to you. Okay. So now what we have to do is, you can see that this is an equation. Okay. Now let us find firstly S minus S by 6. What is S minus S by 6? It will be 6S minus S. So 5S by 6 is equal to 1 plus 4 by 6 plus 7 by 6 square plus 10 by 6 cube and so on. It will go up to infinity, right? So let us consider it as equation number 3. Okay. But you can see that here again, after transforming this series, again the numerator part is forming an AP, right? What is the numerator part? 4, 7, 10. Okay. So the difference here is 7 minus 4 is 3. 10 minus 7 is also 3. So to remove this AP, let us again divide this equation by 6. Okay. So when we again divide this equation by 6, we get 5s upon 6 square is equal to 1 by 6 plus 4 by 6 square plus 7 by 6 cube plus 10 by 6 to the power 4 and so on. Okay, now consider it as equation number 4. Now again we have to repeat the same step, that is 3 minus 4. Okay, we have to subtract equation 4 from equation 3. So what will be LHS? LHS will be 5s upon 6 minus 5s upon 6 square. It is equal to, again we have to leave this 1. Okay, 1 will be as it is and we have to subtract the fractions that have same denominator. So 4 by 6 minus 1 by 6 is 3 by 6. Then 7 by 6 square minus 4 by 6 square will be 3 by 6 square, right? Then 10 by 6 cube minus 7 by 6 cube will be 3 by 6 cube and so on. It will continue. Now you can see that in the numerator part, the AP is removed. Okay, there is not any AP because the numerator part is 3, 3 and 3. So now it is not in the form of AP. Okay, but firstly let us solve the LHS 2. What is LHS? 5s upon 6 minus 5s upon 6 square. So we take the LCM here. Okay, what will be the LCM? 6 square. Okay, then if the LCM is 6 square, then the numerator will be 6 into 5s minus 5s, right? So it will be equal to 30s minus 5s upon 6 square. 30s minus 5s is 25s upon 6 square. We know that 25 is the square of 5. So we can write this expression as 5 square upon 6 square into s, right? Now what it is equal to? It is equal to the RHS part, which is 1 plus 3 by 6 plus 3 by 6 square plus 3 by 6 cube and so on. Now, if we notice a thing, in the right hand side, we find that 3 by 6 is common in all these terms. Again, if we exclude this one, and if we look carefully at all the given terms, then 3 by 6 is common. Okay, so let us take it common. What is 5 square first? It is 25. 6 square is 36. Into s is equal to 1 plus. Remember that we have to exclude 1. Okay, we are not including 1. So if we exclude 1, then at the remaining terms 3 by 6 is common. So let us take 3 by 6 common. Okay, so if we take 3 by 6 common, what will be the remaining terms inside? It will be 1 plus 1 by 6 plus 1 by 6 square plus so on, right? Now you can see that this series is going up to infinity. Okay, it means that this series is a GP. Okay, because it is in the summation and it goes up to infinity. Okay, so for this term we will use a formula which is a upon r minus 1 minus r. Okay, a upon 1 minus r. What is a? A is the first term. You can see what is the first term here? 1. So the value of a is 1. And what is r? R is the common difference. Okay, what is common difference? Second term minus first term. Okay, so what is the common difference here? 1 by 6. Again here we will not include 1. So if we find the common difference between 1 by 6 square and 1 by 6. So the common difference is 1 by 6. So r is 1 by 6. Okay, so we have to use this formula which is a upon 1 minus r. So left hand side will be 25 upon 36 into s is equal to 1 plus 3 by 6 into, now in the place of this given GP, we have to write a upon 1 minus r. What is a? 1 upon 1 minus r. What is r? 1 by 6. All right. So when we simplify it, we get 1 plus 3 by 6 into 1 upon 6 minus 1 upon 6. Okay. We have taken the LCM inside the bracket. So it will be 1 plus 3 by 6 into, this 6 will go to the numerator. So 6 upon 6 minus 1 is 5. 6 and 6 will be cancelled. So it will be 1 plus 3 by 5. What is 1 plus 3 by 5? It is 8 by 5. Okay. Remember that this expression is equal to what? 25 upon 36s. It is the left hand side, right? Now we have only simplified the right hand side. So the equation is 25 upon 36 into s is equal to 8 by 5. So let us find s. What is s? S is the sum of the infinite series, right? So s will be equal to 8 by 5 into 36 upon 25, right? This expression will be reciprocal when it will go to the right hand side. All right. So 8 into 36 is 288. 5 into 25 is 125. So this is the desired value of S. Okay. S is the sum of the infinite series that is given in the question. So for this question, the correct answer is 288 upon 125, which is option C here. I hope the concepts related to these questions are clear to you. Okay. Next question is the value of limit x tends to 1 x square minus 1 into sine square pi x divided by x to the power 4 minus 2 into x cube plus 2x minus 1 is equal to. This is a question that comes from limits. And the first thing that we do in this kind of question is we apply the limit or we put the limit. So what is the limit here? X tends to 1. It means that we have to put x is equal to 1. So let us put the limit first. Numerator will be 1 square minus 1 into sine square pi into x means pi into 1 divided by x to the power 4. 1 power 4 minus 2 into x cube. 1 cube plus 2 into 1 minus 1. So numerator will be 1 minus 1 is 0. 0 into sine square pi is 0 divided by denominator will be 1 minus 2 into 1 is 2 plus 2 into 1 is 2 and minus 1. Plus 1 and minus 1 will be cancelled and minus 2 and plus 2 will be also cancelled. So it will be 0 by 0 form. As we know that whenever we find a 0 by 0 form, then we have to use the L'Hospital's rule, right? Here also we can use the L'Hospital's rule. But before that, we have to see that in the denominator, we have the highest power x to the power 4. So if we use L'Hospital's rule here, then we have to differentiate so many times, right? So let us use some smart trick here. Let us simplify the denominator. What is the denominator? X to the power 4 minus 2x cube plus 2x minus 1. If we simplify this denominator, it will be a lot easy for us to solve this equation. All right. So how can we simplify it? Let us find the factors for this expression. So let us first write x to the power 4 minus 1 together. And what are the remaining terms? Minus 2x cube plus 2x, right? Now you can see that x to the power 4 minus 1. This is in the form of x to the power 4 minus 1 power 4, right? And what is x to the power 4? It can be written as x square whole square minus 1 power 4 can be written as 1 square whole square, right? So it is basically in the form of a square minus b square, which is equal to a plus b into a minus b. Okay, so what is a? A is x square and b is 1 square. So if we write this in the form of a square minus b square, then it will be what? X square plus 1 multiplied by x square minus 1, right? So in place of x to the power 4 minus 1, we can write x square plus 1 and x square minus 1. Then the next terms are minus 2x cube plus 2x. Here minus 2x is common. So when we take minus 2x common, what are the remaining terms? It will be x square and minus of 1, right? Because when we multiply minus 2x into x square, it is minus 2x cube, and minus 2x into minus 1 is plus 2x, right? So we have x square plus 1, x square minus 1 minus 2x and x square minus 1. Now we can see that x square minus 1 is also common, right? So let us take it common. Now the remaining terms are x square plus 1 minus 2x. Again, what is x square plus 1 minus 2x? It is in the form of a minus b whole square. A minus b whole square is a square plus b square minus 2ab. And if we talk about x square plus 1 minus 2x, it is in the same form. It means that this expression is equals to x minus 1 whole square, right? Because x minus 1 whole square is x square plus 1 minus 2 into x into 1, that is minus 2x. So in the place of this expression, we can write what? X minus 1 whole square. Firstly, we have x square minus 1, and now x square plus 1 minus 2x can be written as x minus 1 whole square. Okay, so we have simplified the denominator. Now let us write the expression that is given in the question. In the question, it is given that limit x tends to 1. Now what is the numerator? Numerator is x square minus 1 into sine square pi x. So x square minus 1 into sine square pi x divided by denominator. We have simplified the denominator in this form. So denominator is x square minus 1 into x minus 1 whole square, right? So you can see that x square minus 1 and x square minus 1 will be cancelled. So what are the remaining terms? Sine square pi x divided by x minus 1 whole square. Again, both the numerator and denominator are in the power of 2, means both are in the form of square, right? So we can combine the power. For example, if we have 2 square divided by 3 square, then it can be written as 2 by 3 whole square, right? So here also, if we combine the power, it will be limit x tending to 1 sine pi x divided by x minus 1 and whole square. Okay, we have combined the powers here. Now what we have to do is we have to just transform this expression. To transform this expression, we have to put x is equals to 1 plus h. And if x is equal to 1 plus h, then x minus 1 will be equal to h, right? And also here the limit is given, which is x is equal to 1. It means that the value of x is 1. So in this expression, which is x is equal to 1 plus h, if x is 1, then 1 will be equal to 1 plus h. Then what will be the value of h? H will be equal to 1 minus 1, that is 0. It implies that whenever x will be equal to 1 plus h and the limit is x is equal to 1, then in this case, h will be equal to 0. Okay. So the limits will be also changed now. Limits will be h tending to 0. And now you can see that we have sine pi x. In the place of x, we have to put 1 plus h. So pi 1 plus h divided by x minus 1. Okay. What is x minus 1? It is equal to h, because we have supposed x is equal to 1 plus h. So x minus 1 will be equal to h, and we have whole square, right? Now let us further simplify it. It will be limit h tending to 0 sine pi into 1 plus h is pi plus pi h, right? Divided by h and whole square. Now we have to use a basic concept here, which is sine pi plus theta. Do you know what is sine pi plus theta? Sine pi plus theta is always equals to minus of sine theta. Here we have sine pi plus pi h. It means that the value of theta is pi h. So it will be minus of sine pi h, right? So we can write it as limit h tending to 0. Sine pi plus theta is minus of sine theta. So minus of sine pi h divided by h. And we have whole square. Okay. Since you can see that here there is a square, so this numerator will be positive. Okay. When we do a square of a negative value, then it is always positive. So we can write it as limit h tends to 0 sine pi h divided by h whole square, right? Since it is square, so there is no effect if we write the negative sign or we do not write it. Okay. So now you can see that we have this expression in the form of sine x upon x. And there is a very basic formula, which is limit x tends to 0, sine x divided by x is always equals to 1. Okay. But here you can see that if we consider both these terms are not equal. Okay. In order to get this value equal to 1, we should have sine x divided by x, means both these terms should be equal to each other, right? But here in the numerator we have pi h and in the denominator we have h. So let us do one thing. Let us multiply and divide by pi square. So limit h tends to 0 sine pi h sine square pi h. Okay, let us open this brackets too. So sine square pi h upon h square. Now multiplying and dividing by pi square. All right. So this will be equals to limit h tends to 0 sine pi h square, right? We can write it as sine pi h square divided by, here we have h square into pi square. And again in the numerator we have one more pi square, right? So this will be limit h tends to 0 sine pi h square divided by h square into pi square. See, h square into pi square can be also written as h into pi whole square. Okay, we can combine the powers. So it will be h into pi whole square. Okay, and multiplied by pi square. Again, limit h tending to 0 sine pi h divided by pi h whole square. Okay, again we have combined the powers. See, h into pi is equal to pi into h. Okay, like 2 into 3 is equal to 3 into 2. So it is same only. So we have written pi h. Okay, pi h is also equal to h pi. Okay, so now you can see that we have this expression which is limit h tends to 0 sine pi h upon pi h whole square. Okay, now what is the form? We know that if we have limit x tends to 0 sine x upon x, if we have this form, then it is always equals to 1. You can see that here now both the terms are equal. So it is in the form of limit x tends to 0 sine x upon x. So we know that the value of this term is 1. So if we do its square, then 1 square will be also 1 and multiplied by pi square, right? So 1 into pi square is pi square. Okay. The formula that we have used here is limit x tends to 0 sine x upon x is always equals to 1. All right. Here you can see again we have sine pi h upon pi h. It is in the same form of sine x upon x. Okay, so it's always equals to 1. So for this question, the correct answer is pi square. I hope you are clear with this question. And let us check the options. From all the given options, the correct option is option D here. Next question is, let f such that r to r be a function defined by f of x is equals to x minus 3 power n1 into x minus 5 power n2, where n1 and n2 belongs to n. Then which of the following is not true? In this question, a function is given and we have to identify that which of the following options are not true. So let us have a look towards the options. You can see that in all the options, some values of n1 and n2 is given, for which the function attains local maxima or local minima. It means that we have to find the values at which function attains local maxima or local minima. But remember that we have to choose the option that is not true. Okay, it means that out of these 4 options, 3 options are true and 1 is not true. So we have to find the option that is not true. So basically what we have to find first, we have to find that at what points this function attains local maxima, local minima, right? Then only we can choose the option. So whenever a function is given to us and we have to find its local maxima or local minima, then the first thing we do is we find its derivative. It means we have to find the derivative of the given function. You can see that in this function, both these values are in product form or in multiplication. So we have to use a formula of derivative, which is d by dx of u into v. It is equal to u into d by dx of v plus v into d by dx of u. Okay, if we consider this as the first and if we consider this as second, then the formula is first into d by dx of second plus second into d by dx of first. All right, so for the given function, let us consider this as first and let us consider this as second. Okay, so f dash x will be equal to first into d by dx of second. What is the first term? X minus 3 power n1 into d by dx of second term. Second term is x minus 5 power n2 plus second into d by dx of first. Second term is x minus 5 power n2 into d by dx of first. What is first term? X minus 3 power n1. Okay. Now again we have to use a formula of differentiation, that is d by dx of x to the power n. Do you know what is d by dx of x to the power n? It is n into x power n minus 1. All right. What is the formula for d by dx of x to the power n? It is n into x power n minus 1. Here you can see that both these expressions are in the form of d by dx of x to the power n. So when we use this formula, we get f dash x is equals to x minus 3 power n1 into d by dx of x minus 5 power n2. Here you can see that x minus 5 is x if we compare with the formula. And what is the value of n? The value of n is n2. So formula will be n into x power n minus 1. So n2 into x minus 5 power n2 minus 1, right? Plus next term is x minus 5 power n2 into d by dx of x minus 3 power n1. What is the formula? N into x power n minus 1. Here the value of x is x minus 3 and the value of n is n1, right? So n means n1 into x. What is x? X minus 3 power n1 minus 1. So this is the basic differentiation of this given function. All right. Now, if we take these two terms common from this expression, then we get f dash x is equal to. Firstly, let us take common. Okay. We are taking two terms common. What are the two terms? We are taking x minus 3 power n1 minus 1 and x minus 5 power n2 minus 1. These both terms are common. Okay, so if we take both these terms common, then what is remaining here? Here we have x minus 3. Okay, x minus 3 and we have n2. So multiplied by n2, you can see that in the first term, we have already taken x minus 3 power n1. So what is remaining? X minus 3 and we have n2. In the second term, we have x minus 5, right? So plus x minus 5 and we have n1. So these are the remaining terms when we take x minus 3 power n1 minus 1 into x minus 5 power n2 minus 1 common. All right. Now when we further simplify it, f dash x will be equal to x minus 3 power n1 minus 1 into x minus 5 power n2 minus 1. Now when we simplify these brackets, so what the value we get it? X minus 3 into n2 is what? X n2 minus 3 n2. We have to multiply both these values with n2 plus x minus 5 into n1. X n1 minus 5 n1. Okay. So f dash x will be equal to x minus 3 power n1 minus 1 into x minus 5 power n2 minus 1. Again, in multiplication, you can see that we have x n2 and x n1. Okay, so if we take x common, then we get n1 plus n2, right? Then what are the remaining terms? Minus 5n1 minus 3n2. All right. Now again, if from this bracket we take n1 plus n2 common, so let us see what we get. F dash x is equal to x minus 3 power n1 minus 1 into x minus 5 power n2 minus 1. Now we have to take n1 plus n2 common. Okay, so if we take it common, then in first term, the remaining term is x minus. In the second term, what will remain? 5n1 plus 3n2 divided by n1 plus n2, right? We have taken minus sign also common. You can check it. If we multiply n1 plus n2 again, then we get the same expression, right? So this is the basic trick to check that expression is correct or not whenever we are taking any value common. Okay, after we take common, we further multiply it and we get the expression back. n1 plus n2 into x is x into n1 plus n2 and n1 plus n2 into 5n1 plus 3n2 will be 5n1 plus 3n2 because n1 plus n2 will be cancelled if we multiply this inside, right? So we have taken this common, right? So now what we have to do is we just have to hit and try all the options and we have to find that which option is not true for this given derivative of f of x, right? So when we hit and try all the options, we find that option C is not true. What is option C? n1 is equal to 3 and n2 is equal to 5. All right. So let us check it. n1 is equal to 3 and n2 is equal to 5. We have to put both these values in f dash x. So f dash x will be x minus 3 power n1 minus 1. What is n1? 3. 3 minus 1 is 2 multiplied by x minus 5 power n2 minus 1. What is n2? 5. 5 minus 1 is 4. Okay. What is n1 plus n2? 3 plus 5. So into 8. Then in bracket we have x minus 5 into n1. 5 into 3 is 15 plus 3 into n2. 3 into 5 is again 15 divided by n1 plus n2. It will be 8. Okay. 3 plus 5 is 8. So f dash x is equal to x minus 3 square into x minus 5 power 4 into 8 and x minus 15 plus 15 is 30 by 8. Okay. So this is the required value of f dash x when n1 is equal to 3 and n2 is equal to 5. Okay. So here you can see that these terms in these terms, there is no point of relation because here, what are the powers? The powers are even. Okay. So we do not get any point here. Okay. What is the remaining term? X minus 30 by 8. So it is very clear that x is equal to 30 by 8 is the point of minima, right? Because in this term, we do not get any point because the powers are even. Okay. We do not get any point for the correlation, right? So the remaining portion is x minus 30 by 8. You can see that at x is equal to 30 by 8, we have the minima. Okay. But let us check option C again. Option C says that f attains local maxima, but actually we are getting the value for minima, right? It means that there is only a single critical point for the derivative of f of x. Okay. So for this question, the correct option is option C. Remember that this option is not true. We have to select the option that is not true. So option C is not true. Okay. Because at both these points, we get local minima. But option C says that it is local maxima. That is why it is not true. And we also understand that there is only a single critical point for the derivative of f of x. I hope you are clear with this question. Next question is, let f be a real valued continuous function on the interval 0, 1 and f of x is equal to x plus integral of 0 to 1 x minus t into f of t dt. Then which of the following points x, y lies on the curve y is equal to f of x? So basically we have to find the points that will lie on the curve y is equal to f of x. In order to find the points, we first need the value of f of x. And what is f of x? It is a function that is given in the form of integration. So firstly, let us write the function. F of x is equal to x plus integral of 0 to 1 x minus t into f of t dt. So this will be x plus integral of 0 to 1 x into f of t dt, right? We are opening the brackets, minus integral of 0 to 1 t into f of t dt. Now, notice one thing here, that for this integration, what is the variable of integration here? The variable of integration is t. Since here there is dt, it means that for this integration, x will be a constant, right? So first term is x plus, now integral of 0 to 1 x into f of t dt. Since the variable of integration is t, so x will be constant. So x will come out. Integral of 0 to 1 f of t dt minus integral of 0 to 1 t into f of t dt. Now you can see that x is common in the first two terms. So let us take x common. So when we take x common, the remaining terms will be 1 plus integral of 0 to 1 f of t dt minus integral of 0 to 1 t into f of t dt, right? Now you can see that first term is a multiple of x and second term is just a term for integration, right? We know that both these terms are definite integrals. It means that its value will be actually a constant, right? So except x, these two terms are actually a constant. So let us do one thing. Let f of x be equal to x into a minus b, means let us consider this term as a, okay, because we know that it is a definite integral, so its value will be a constant. So we are considering this expression is equal to a and this expression is equal to b. So we will have f of x is equal to x into a minus b. Okay. Now it can be also written as f of x is equal to ax minus b, right? X into a or a into x. It is same only. Okay. Now we have f of x is equal to a into x minus b. What is a here? A is 1 plus integral of 0 to 1 f of t dt. And what is b? B is integral of 0 to 1 t into f of t dt, right? This is the values of a and b. Now, if we want to calculate a, we need f of t. So let us do one thing. Let us find f of t. If we have f of x, then we can easily find f of t. We just have to replace t with x, right? So we have at minus b. This is the value of f of t. Now let us do one thing. Let us calculate a and b separately. What is a? A is 1 plus integral of 0 to 1 f of t dt. So substituting the value of f of t here, it will be 1 plus integral of 0 to 1. What is f of t? At minus b and dt. Now let us integrate this term. So a will be equal to 1 plus. Now integral of 0 to 1. At dt, right? Minus b dt. And again here, integral of 0 to 1. Now, its integral will be 1 plus. Integral of at dt will be, a is a constant, a will come out, and t square upon 2 minus integral of b dt will be bt, right? We know that integral of x dx is x square upon 2. That is actually x power n plus 1 upon n plus 1. Here the power of x is 1. All right. So we have this term. And what are the limits here? The limits are 0 to 1. So when we put 1, then it will be a by 2 minus b. We have to substitute 1 in the place of t. And when we put 0, this whole term will be 0. So actually we have a by 2 minus b. Now this is equal to a. So a is equal to 1 plus a by 2 minus b. Now let us do one thing. Let us separate the terms of a on the left hand side. So we have a minus a by 2 is equal to 1 minus b. Now taking the LCM, 2a minus a divided by 2 will be equal to 1 minus b. 2a minus a is a by 2 is equal to 1 minus b. So from here we can say that a is equal to 2 into 1 minus b. This is a relation formed between a and b. So now consider it as equation number 1, right? Similarly, let us do one thing. Let us solve the b part. What is the value of b? The value of b is integral of 0 to 1 t into f of t dt. All right. So b is integral of 0 to 1 t into f of t dt. Now let us multiply t. When we multiply t, this term will be integral of 0 to 1 t into f of t and dt. Now what is f of t? 0 to 1 t into f of t is actually at minus b. See, we have already found this value. F of t is at minus b. So substitute it here. So t into at minus b and then dt. Now when we multiply t, this expression will be b is equal to integral of 0 to 1 at square dt minus integral of 0 to 1 b into t is bt dt, right? Again we have to integrate this. So integral of 0 to 1 at square. Now a is a constant. Integral of t square dt will be t power 2 plus 1 upon 2 plus 1. So t cube upon 3 minus b is a constant. Now integral of t dt will be t square upon 2 by using the formula, which is integral of x dx is equal to x power n plus 1 upon n plus 1, right? So this is the value of b, and here the limits are again 0 to 1. So let us put the limits. When we put the limits, it will be a by 3 minus b by 2. Okay, when we put t is equal to 1, we get a by 3 minus b by 2, and when we put 0, the expression will be 0. So what we have is b is equal to a by 3 minus b by 2. Now let us take all the terms of b on the left hand side. So we have b plus b by 2 is equal to a by 3. On taking the LCM, 2b plus b divided by 2 is equal to a by 3. Now what is 2b plus b? It is 3b divided by 2 is equal to a by 3. So if we want it in the terms of a, so this 3 will go to the left hand side. So it will be multiplied. So 3 into 3b upon 2 is equal to a. Now what is 3 into 3b? It is 9b. So 9b upon 2 is equal to a. So consider this as equation number 2. You can see that we have two equations. First equation is a is equal to 2 into 1 minus b. And what is the second equation? Second equation is a is equal to 9 into b upon 2. Now let us do one thing. Let us substitute a is equal to 9b upon 2 in equation number 1. So what is equation number 1? A is equal to 2 into 1 minus b. So what is the value of a that we have to substitute? 9b upon 2. So we are substituting this value of a in equation 1. So we have 9b upon 2 is equal to 2 into 1 minus b, right? So 9b upon 2 is equal to 2 minus 2b. Now, if we want the value of b, then 9b upon 2 plus 2b is equal to 2. When this term will go to the left hand side, it will be positive. Now let us take the LCM. LCM is 2. Numerator will be 9b plus 2 into 2b is 4b is equal to 2. 9b plus 4b is 13b divided by 2 is equal to 2. So we have 13b is equal to 2 into 2 will be 4. So the value of b will be 4 by 13. Since we have the value of b, we can easily find a by using the second equation. What is second equation? 9b upon 2 is equal to a. So 9 upon 2 into b is equal to a. Now substitute the value of b here. So 9 by 2 into b. What is b? 4 by 13. It is equal to a. So 2 and 4 will be cancelled here. 9 into 2 is 18. 18 divided by 13 is equal to a. Now we have the value of a and b. It means we can actually find the value of f of x. Remember what is f of x? F of x is actually ax minus b. So let us substitute the value of a and b here. The function f of x is in the form of ax minus b, right? So what is a? 18 by 13 into x minus b. So it will be actually 18x by 13 minus b. What is b? 4 by 13. So we can write it as 18x minus 4 upon 13. This is the value of f of x. So f of x is equal to 18x minus 4 upon 13. In the question, a function is given which is in the form of y is equal to f of x. It means that this is in the form f of x is equal to y. Okay, now let us do one thing. We have to find the pairs of x and y which will satisfy this given condition. All right, it means when we put the value of x, we should get the value of y. So now let us do one thing. We have 4 different options. We have to hit and try here. What is the first option? 2, 4. So let us check it with 2, 4. When x is equal to 2, we should get y is equal to 4. So let us put x is equal to 2 here. So f of 2 is equal to 18 into 2 minus 4 divided by 13. What is 18 into 2? 36. 36 minus 4 divided by 13. So it is 32 divided by 13. Okay, we cannot get 4. So this option is not correct. Now let us check it with second option. What is the second option here? 1, 2. So if we check for 1, 2, it means x is equal to 1 and y should be equal to 2. So when x is equal to 1, f of 1 will be 18 into 1 minus 4 divided by 13. 18 into 1 is 18. 18 minus 4 is 14 by 13. Okay. It is not equal to 2. Means the value that should we get is 2. The value we should get is 2, right? When x is equal to 1, y should be 2. But again, y is what? 14 upon 13. You can see that f of x is equal to y. Means the value of this should be equal to y. But here y is 14 upon 13. So this option is also not correct. Now let us check the third option. What is the third option? 4, 17. So when we check for 4, 17, x is 4 and y should be 17. So f of 4 should be equal to 18 into 4 minus 4 divided by 13, right? Now 18 into 4. 18 into 4 is 72. 72 minus 4 divided by 13, right? What is 72 minus 4? It is 68 divided by 13, right? 68 divided by 13 is the value of y. But according to the pair, y should be 17. So this option is also wrong. Now, let us check for the last option. What is the last option? Last option is 6, 8. So for the option 6, 8, x should be 6 and y should be 8. So f of 6 will be equal to what? 18x minus 4 by 13. So 18 into 6 minus 4 by 13, right? Now 18 into 6 is 108. 108 minus 4 by 13. What is 108 minus 4? It is 104 by 13. And when we divide 104 by 13, we get 8. 13 into 8 gives 104. So this ordered pair is absolutely correct. So for this question, the correct option is option D, that is 6, 8. I hope you are clear with this question. Next question is, if integral of 0 to 2 under root of 2x minus under root of 2x minus x squared dx is equal to integral of 0 to 1 minus under root of 1 minus y square by 2 dy plus integral of 1 to 2 minus y square by 2 dy plus I, then I equals. So basically we have to find the value of I. To get the value of I, which is on the right hand side, we first need to evaluate the value of left hand side. So what is the integral part on the left hand side? It is integral of 0 to 2 under root of 2x minus under root of 2x minus x square dx. So it will be equal to integral of 0 to 2 under root of 2x dx minus integral of 0 to 2 under root of 2x minus x square dx. To solve the first term, it is very easy because it is integral of root 2x dx. Root 2 is a constant, so it will be outside. Then we have integral of 0 to 2 root x dx minus integral of 0 to 2 under root of 2x minus x square dx. To solve the first part, which is integral of 0 to 2 root x dx, we have to use a formula which is integral of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. Here we have integral of root x dx. Root x is actually x power 1 by 2. So this is equal to integral of x power 1 by 2 dx, means the value of n is 1 by 2. So if we use this formula, integral of x power 1 by 2 dx will be equal to x power 1 by 2 plus 1 divided by 1 by 2 plus 1, since n is equal to 1 by 2. 1 by 2 plus 1 is 3 by 2. So x power 3 by 2 divided by 3 by 2. So the value of integral of root x dx is x power 3 by 2 divided by 3 by 2. So it will be root 2 multiplied by x power 3 by 2 divided by 3 by 2. And what are the limits? Limits are 0 to 2 minus. Now the second part is under root of 2x minus x square. In order to solve this integral part, we first need to simplify this expression just to make it a perfect square. So let us see how we can make it a perfect square. The expression is under root of 2x minus x square. It can be also written as under root of minus x square plus 2x. We have just swapped both the values, right? Now, in order to make it a perfect square, let us do one thing. Let us add 1 and let us subtract 1. So it will be under root of minus x square plus 2x minus 1 plus 1. Okay, because if we are adding 1, then also we have to subtract 1 just to balance the expression. Now it can be written as 1 minus x square plus 2x minus 1. We have written this one on the first term. Okay, now under root of 1 minus, if we take minus common from these three terms, then it will be x square plus 1 minus 2x. X square plus 1 minus 2x is basically equal to x minus 1 whole square, because x minus 1 whole square is equal to x square plus 1 minus 2x by using the formula for a minus b whole square, which is a square plus b square minus 2ab. All right, so this can be written as 1 square. See, 1 can be written as 1 square minus x square plus 1 minus 2x is x minus 1 whole square. Now you can see that this expression is in the form of a perfect square. Okay, we have transformed this given expression into a perfect square. So let us substitute this value. It will be integral of 0 to 2. What is root 2x minus x square? It is equal to under root of 1 square minus x minus 1 square. So under root of 1 square minus x minus 1 square dx. This is in the form of under root of a square minus x square. So the basic formula is integral of under root of a square minus x square dx is equal to x by 2 into under root of a square minus x square plus a square by 2 into sine inverse of x upon a plus c, where c is a constant. All right, so we have to use this formula in order to solve this expression. But first let us solve this left part. What is the left part? Root 2 into, you can see that this 3 by 2 can come out of this bracket, so it will be 2 by 3. Remaining is x power 3 by 2 and the limits are 0 to 2 minus, when we solve this integral part by using the formula of under root of a square minus x square, then its value will be equal to pi by 2. All right. Now let us solve this part. Root 2 into 2 by 3. We have to apply the limits, which is 2 and 0. So applying the limit 2, it will be 2 power 3 by 2. When we apply 0, it will be 0, right? Now 2 power 3 by 2 can be written as 2 power 1 plus 1 by 2. Okay. You can see that 2 power 3 by 2 is actually equal to 2 power 1 plus 1 by 2 because 1 plus 1 by 2 is 3 by 2. Again, 2 power 1 plus 1 by 2 can be written as 2 power 1 into 2 power 1 by 2 because we know that when base is same, then power is added. Now, what is 2 power 1? It is 2. What is 2 power 1 by 2? 2 power 1 by 2 is actually root 2, right? So, root 2 into 2 by 3. 2 power 3 by 2 is actually 2 into root 2. So, 2 into root 2 minus 0 and minus pi by 2. So, it will be equal to root 2 into 2 by 3 into 2 into root 2 minus pi by 2. Root 2 into root 2 is 2. 2 into 2 is 4 and 4 into 2 is 8. So it will be 8 by 3 minus pi by 2. This is the exact value of the integral part of left hand side. Okay, now let us solve the right hand side. Right hand side is this whole expression. So let us write it. RHS is equal to integral of 0 to 1 minus under root of 1 minus y square by 2 dy plus integral of 1 to 2 minus y square by 2 dy and plus I. Now you can see that here the constant terms are 1 and 2. So firstly let us take them out. So 1 plus 2. Then we have minus of integral of 0 to 1 under root of 1 minus y square and minus of integral of 0 to 1 y square by 2 dy. Okay. Plus integral of 1 to 2 minus of y square by 2 dy plus I. So this is equal to 1 plus 2 is 3. 3 minus integral of 0 to 1 under root of 1 minus y square dy minus integral of 0 to 1 y square by 2 dy plus minus will be again minus integral of 1 to 2 y square by 2 dy plus I. Now we can see this. Both the terms are equal. Only the limits are different. What are the limits? 0 to 1 and 1 to 2. It means that here the limit is broken down into two parts. 0 to 1 and 1 to 2. So what is the combined limit? Combined limit is 0 to 2. Okay. So we can also write the combined limit, right? Because 0 to 2 means 0 to 1, then 1 to 2. So combinedly we can write the limits of both these terms as 0 to 2. So it will be 3 minus integral of 0 to 1 under root of 1 minus y square dy. And when we take minus common, it will be y square by 2 dy plus y square by 2 dy. But since we are combining the limits, so it will be minus of integral of 0 to 2 y square by 2 plus I. Now again, we have to use the same formula for integral of x to the power n dx to solve this part. And integral of 0 to 1 minus y square in under root is equal to pi by 4. So 3 minus, what is the value of integral of 0 to 1 under root of 1 minus y square? It is pi by 4. Minus, when we integrate this value, what is the value? Integral of y square by 2. We have to use the formula which we have used, that is integral of x to the power n dx is equal to x power n plus 1 upon n plus 1. Okay. In the place of x we have y. You can see that 1 by 2 will be constant. So let us take it outside. Then y power 2 plus 1 divided by 2 plus 1. Because the formula is integral of x to the power n dx is x power n plus 1 divided by n plus 1. Right. So this will be 1 by 2 into y cube upon 3. So it will be y cube upon 6. Right. So we can write it as y cube upon 6 and the limits are 0 to 2 plus I. Okay. So it will be 3 minus pi by 4 minus, when we put the limits here, y cube means we have to put 2 in the place of y. So 2 cube is 8. 8 by 6 minus, when we put 0, it will be 0. Then plus I. So it will be 3 minus pi by 4 minus 8 by 6 is actually 4 by 3. So minus 4 by 3 plus I. Now 3 minus 4 by 3. When we take the LCM, 3 minus 4 by 3 is 5 by 3 minus pi by 4 plus I. So the value of RHS is 5 by 3 minus pi by 4 plus I. Okay. Since LHS is equal to RHS, so we have to equate both the values. Okay. So what is the value of LHS? 8 by 3 minus pi by 2. So 8 by 3 minus pi by 2 is equal to RHS. What is the simplified form of RHS? 5 by 3 minus pi by 4 plus I. Okay. So from here easily we can get the value of I. I will be equal to 8 by 3 minus pi by 2 minus 5 by 3 plus pi by 4. Okay. We have transformed this expression to the other side to get the value of I. So I will be equal to 8 minus 5 is 3. 3 by 3 is 1. Okay. 1 minus pi by 2 plus pi by 4. So this will be equal to 1 minus pi by 4. So what is the value of I? The value of I is 1 minus pi by 4. But if we look at the options are in the form of integral, right? They are not in the form of constants or numbers. So what is the value of I? It is actually 1 minus pi by 4. But we have to write this value in the form of integral. Okay. So for the first term, it is very easy. Integral of 1 will be 1 because it is a constant. So 1 can be written in the integral as integral of 1. Okay. And in all the options, the limits are 0 to 1. So the limits are 0 to 1. Now, if we talk about pi by 4, what can be the integral for pi by 4? We have to find a value whose integral is pi by 4. Okay. So we have actually solved it. We have seen that integral of 1 minus y square dy is equal to pi by 4, right? It means that in the place of pi by 4, we can write integral of 1 minus y square in the under root. Okay, because the integral value of under root of 1 minus y square is pi by 4. So if we have to write pi by 4 in the form of integral, then it will be integral of 0 to 1 under root of 1 minus y square dy, right? So it will be integral of 0 to 1 under root of 1 minus y square dy. Okay. Now both the limits are same. So let us combine them. Integral of 0 to 1, 1 minus under root of 1 minus y square and dy. So now let us check all the options. If we check all the options, the correct option here is option C, which is integral of 0 to 1, 1 minus under root of 1 minus y square dy. So the correct option for this question is option C here. Next question is, if y is equal to y of x is the solution of the differential equation 1 plus e power 2x dy by dx plus 2 into 1 plus y square into e power x is equal to 0 and y of 0 is equal to 0, then 6 into y dash 0 plus y into log base e root 3 whole square is equal to. It is a very interesting question. Solution of a differential equation is given, which is y is equal to y of x. This is the solution. And another quantity is given, which is y of 0 is equal to 0. Okay, it means that 0 will be equal to y of 0, right? When we compare both this value, then it means that when y is 0, x will be 0. It means that when we put x is equal to 0 here, we get y is equal to 0. Now, this is the solution of the differential equation. Firstly, let us look at the differential equation that is given here. The differential equation is 1 plus e power 2x into dy by dx plus 2 into 1 plus y square into e power x is equal to 0. Now let us do one thing. Let us separate the variables. Let us take the variables of y on one side and let us take the variables of x on another side. So it will be 1 plus e power 2x into dy by dx. Now let us take this term to the right hand side. So it will be minus of 2 into 1 plus y square into e power x. Now let us do one thing. Let us take this dx on the right hand side and let us take this 1 plus y square on the left hand side. So we will have 1 plus e power 2x into dy upon 1 plus y square is equal to minus 2 into e power x dx, right? This minus 2 will be multiplied with e power x. And since we are taking dx to the right hand side, it will be in the multiplication form. And here 1 plus y square is in multiplication form. So when it will go to the other side, it will be in the division form. Now let us take this term to the right hand side. It is also in the multiplication form, means it will go in the divide. So we will have dy upon 1 plus y square is equal to minus 2 into e power x dx divided by 1 plus e to the power 2x. Right? So we have separated the variables here. Now let us do one thing. Let us integrate both the sides. This minus is a sign, so it will come out. Now, to integrate this, we need some formulas. Integral of dx upon 1 plus x square is always equals to tan inverse x, right? You can see that the first part is in the same form, dy upon 1 plus y square. So its integral will be tan inverse of y. Now it is equal to minus. Again, 2 is a constant, so 2 will come out. Now we have integral of e power x dx divided by 1 plus e power 2x. Now how to integrate this term? Let us do one thing. Let us put some values, right? Let us put e to the power x is equal to t. If we are putting any value, then we have to differentiate both the sides. So when we differentiate both the sides, d by dx of e power x is e power x, right? So e power x, then we have to differentiate x, okay? So dx is equal to d by dx of dt is dt, right? So e power x dx is equal to dt. The formula which we have used here is d by dx of e power x is equal to e power x, right? Now this is the expression here. We know that e power x dx is equal to dt, right? Means this whole term will be equal to dt, all right? And in the denominator, we have 1 plus e power 2x. See, what is e power x? E power x is equal to t, right? It means that e power 2x will be t square, right? So the expression becomes tan inverse of y is equal to minus 2 into integral of, this term is dt, which is the numerator, dt upon 1 plus e power 2x will be t square, right? So again, this is in the form of dt upon 1 plus t square. So we have to use this formula again, which is integral of dx upon 1 plus x square is tan inverse x. So its value will be tan inverse y is equal to minus 2 into tan inverse of t, right? We have to use the same formula and plus c, where c is a constant. Now again, we can substitute the value of t here. What is t? T is e to the power x. So let us substitute the value. Tan inverse of y is equal to minus of 2 into tan inverse of e to the power x plus c. Now you can see that one expression is given in the question, which is y of 0 is equal to 0. So this is the expression y of 0 is equal to 0, and the solution of the differential equation is also given, which is y of x is equal to y. It means that when we compare both these terms, when x is equal to 0, then y is also equal to 0. So let us do one thing. Let us substitute x is equal to 0 and y is equal to 0 in this expression. Okay. So it will be tan inverse of y. What is y? 0. Is equal to minus 2 into tan inverse of e power x. What is x? 0. Plus c. So this will be tan inverse of 0 is equal to minus 2 into tan inverse of e power 0. We know that in exponents, there is a rule that anything raised to 0 is always equals to 1. So we have tan inverse 1 plus c, right? So tan inverse of 0 is 0, right? And this will be equal to what? 2 tan inverse 1. Now what is the value of tan inverse 1? Do you know what is the value of tan inverse 1? It is pi by 4. So when we substitute here, minus 2 into tan inverse 1. Tan inverse 1 is pi by 4 and plus c. So 2 ones are 2 and 2 twos are 4. So we have 0 is equal to minus pi by 2 plus c. So from here we can get the value of c, right? C will be equal to plus pi by 2. Now let us put this value of c in this equation, right? So when we put the value of c here, then we have tan inverse of y is equal to minus 2 into tan inverse of t plus c. What is c? Pi by 2. See, we have substituted the value of c in this equation. Okay, this is the equation, right? So tan inverse y will be equal to minus 2 into tan inverse of t plus c. What is c here? C is pi by 2. So this is the expression now. Now let us take this terms of tan inverse on one side. So we have tan inverse of y plus 2 into tan inverse of t is equal to pi by 2. Now we have to substitute the formula of 2 tan inverse x. What is the formula of 2 tan inverse x? We know that 2 tan inverse x is equal to tan inverse 2x divided by 1 minus x square. So we have to use this formula here. First term will be as it is, tan inverse y plus. Now we have to substitute the formula of 2 tan inverse x. Here we have 2 tan inverse t. So what is the formula? Tan inverse 2x means 2 into t. So 2t upon 1 minus x square. So 1 minus t square. This is equal to pi by 2. Now we have to use another concept, which is tan inverse x is equal to 1 by cot inverse x, right? What is the value here? Tan inverse 2t upon 1 minus t square. So it will be equal to 1 upon cot inverse 2t upon 1 minus t square. Now what is 1 upon cot inverse? It can be written as cot inverse 1 minus t square upon 2t, right? So its value will be in terms of cot inverse. This is the value in terms of cot inverse. We know that tan inverse is the reciprocal of cot inverse, right? So this will be tan inverse y plus cot inverse 1 minus t square upon 2t is equal to pi by 2, right? Now we know one more concept, that tan inverse x plus cot inverse x is equal to pi by 2. But when this expression is equal to pi by 2, when the input inside the tan inverse is equal to input inside the cot inverse, means x is equal to x. Okay, but here we are getting tan inverse y plus cot inverse 1 minus t square upon 2t is equal to pi by 2. Since this value is pi by 2, means the input of tan inverse is equal to the input of cot inverse. So from here we can say that y is equal to 1 minus t square upon 2t. Okay, now we have the value of y in terms of t. Y is equal to 1 minus t square upon 2t, right? Now we have to find a value, which is, we have to find log base e root 3. What is this value? Y of log base e root 3 square. Okay, it is in the terms of y of x, right? So we have to use this expression, which is y of x is equal to y. It means that this is the form y of x, right? It means the value of x is log base e root 3, right? So let us put x is equal to log base e root 3. Now before that, we have assumed a value which is t is equal to e power x, right? So when we put the value of x here, then t will be equal to e power log base e root 3, right? And therefore, t will be equal to root 3. Okay, so when we put x is equal to log base e root 3, we get t is equal to root 3, right? So we can write when x is equal to log base e root 3, then t is equal to root 3. We have substituted it in the expression, which is t is equal to e to the power x. Now let us put this value of t in here. Okay, we know that y is equal to 1 minus t square upon 2t. So let us put the value of t. It is 1 minus t square. What is root 3 square? Root 3 into root 3 is 3 divided by 2 into t, 2 into root 3. So 1 minus 3 is minus 2 upon 2 root 3. Okay, so this 2 and 2 will be cancelled. So we will have minus 1 upon root 3. This is the value of y. So we can say that when x is equal to log base e root 3, then y is equal to minus 1 upon root 3, right? This is the value we have obtained. We can write that y of x is equal to y. So what is x here? Y of log base e root 3 is equal to y minus 1 upon root 3. Means when we have substituted x is equal to log base e root 3, then we got the value of y, which is minus 1 upon root 3, right? Now we have to find one more value. We have to find y dash 0. Okay, y dash 0, it represents when x is equal to 0, then y will be also equal to 0, right? So let us do one thing. Let us write this differential equation and put x is equal to 0 and y is equal to 0, right? So let us write the differential equation first. The differential equation is 1 plus e power 2x into dy by dx plus 2 into 1 plus y square into e power x is equal to 0, right? We have to put x is equal to 0, right? And we have to put y is equal to 0, right? So before that, let us concentrate on this part. See, we have to find y dash 0, okay? But we don't know the value of its output. We have the expression y of x is equal to y, okay? It means that y of 0 will be what? Y dash 0, okay? Y dash means differentiation, okay? So let us put x is equal to 0 and let us see what will get the value of y dash 0, right? So when we put the value here, we have 1 plus e power 2x. 2x means 2 into x. So 2 into 0 is 0. Then dy by dx. It is actually what? It is y dash 0. So y dash 0 plus 2 into 1 plus y square. Y square means y of 0 square. Then e power x. E power x is again e power 0. This is equal to 0, right? Now you can see 1. 1 plus e power 0 will be 1. Anything raised to 0 is 1 into y dash 0 plus 2 into 1 plus y dash 0 square. What is y dash 0? It is actually equal to 0. So 0 square is 0. See, we know that y of 0 will be 0 because we have the expression y of x is equal to y. It means when x is equal to 0, y will be 0, right? So y of 0 whole square will be also equal to 0. So it is 0 into e power 0. Anything raised to 0 is 1. So into 1, it is equal to 0. Now 1 plus 1 is 2. 2 into y dash 0 plus 2 into 1 plus 0. Again 1 into 1. 2 into 1 into 1 is 2 only, right? So this is equal to 0. Now 2 into y dash 0 will be equal to minus 2, right? So y dash 0 will be equal to minus 2 upon 2. This 2 and 2 will be cancelled. So we have minus 1. Okay. So what is the value of y dash 0? It is minus 1. So we have the value of y dash 0. Now at last we have to find the value of 6 into y dash 0 plus y into log base e root 3 whole square, right? We have both the values. So let us substitute the value 6 into y dash 0. What is y dash 0? Minus 1 plus y into log base e root 3 means y of log base e root 3. It is actually y of log base e root 3. What is the value of y of log base e root 3? It is minus 1 upon root 3. It's square. You can see that square is given here. So minus 1 by root 3 square is what? Minus 1 into minus 1 divided by root 3 into root 3. So it will be 1 by 3. So it will be 1 by 3, right? Now 6 into, when we take the LCM, LCM will be 3. So we will have minus 3 plus 1 divided by 3. So 6 into minus 3 plus 1 is minus 2 divided by 3. 3 ones are 3 and 3 twos are 6. So 2 into minus 2 is minus of 4. So this is the value of the given expression. So for this question, the correct answer is minus of 4. I hope you are clear with this question. In this question, we have used many concepts related to differentiation, and also we have used the method of substitution. That is, we have taken a value and then we have substituted it in an equation, right? In this way, we have found the given expression. So for this question, the correct answer is minus of 4. And hence the correct option is minus of 4, which is option C here. I hope you are clear with this question. Next question is, let P y square is equal to 4ax, where a is greater than 0, be a parabola with focus S. Let the tangents to the parabola P make an angle of pi by 4 with the line y is equal to 3x plus 5 touch the parabola P at A and B. Then the value of A for which A, B and S are collinear is. It is a very interesting question. Let us understand this question by making a diagram. It is given that we have a parabola whose equation is y square is equal to 4ax. So let us consider this as the coordinate axis. Since the equation of parabola is in the form of y square is equal to 4ax and a is greater than 0, it means that the parabola will lie here. So consider it as the given parabola. It is also given in question that there are two different tangents to the parabola which makes an angle of pi by 4 with the line y is equal to 3x plus 5, right? So firstly, let us make the two different tangents for this parabola. So the first tangent will be in this form, right? And the second tangent will be in this form, right? So consider it as the two tangents. Let this tangent be T1 and let this tangent be T2. It is also given that both the tangents touch the parabola at point A and B. It means that this is point A and this is point B. Now let us do one thing. Let us join point A and B. So when we join it, it is actually the focal chord of the parabola, right? You can see that this line is actually the focal chord for the parabola, right? And what is the focal chord? Focal chord is the line that always passes through the focus. It means that this point is focus. And it is given that we have focus S. So this point is S. And how focus is denoted? We know that focus is always equals to A comma 0. It means that the coordinates here are A comma 0, right? It is also given that both the tangents makes an angle of pi by 4. But when both the tangents makes an angle of pi by 4 when they intersect with the line y is equal to 3x plus 5. So let us make a line here. Let this be the line which is y is equal to 3x plus 5. When tangent T1 intersect with this line, an angle is formed which is pi by 4. And when tangent T2 intersect with this line, another angle is formed which is pi by 4. So this is the required diagram. I hope the diagram is clear to you. Now we have an equation for parabola and an equation for line which is y is equal to 3x plus 5. It is in the form of y is equal to mx plus c, right? What is m? M is the slope. So when we compare both these equations, we can say that we have slope of line. What is slope of line? It is the value of m. What is m here? M is 3. So slope of line is 3. Okay, this is the first slope that we have found. Now let us consider the slope for tangent T1 be m, right? When we have two different slopes and an angle, then we can use a formula for tan theta. Do you know what is the formula for tan theta when we have two different slopes? Tan theta is equal to mod of m1 minus m2 divided by 1 plus m1 into m2. Okay, here what is m1? The first slope. Okay, so what is the value of m1? It is 3. And what is the value of m2? The second slope for tangent T1, right? So let us substitute it. And what is theta? Theta is pi by 4. So tan pi by 4 is equal to mod of m1, 3 minus m2, m divided by 1 plus m1 into m2. 3 into m is 3m, right? Now, what is the value of tan pi by 4? We know that the value of tan pi by 4 is 1. So 1 will be equal to mod of 3 minus m divided by 1 plus 3m. Since here we have mod, so when this mod will be removed, we will have two values, positive and negative, right? So 3 minus m divided by 1 plus 3m will be equal to positive 1. And another value will be 3 minus m divided by 1 plus 3m is equal to minus 1. All right. So let us solve both these parts. Let us cross multiply here. So we have 3 minus m is equal to 1 plus 3m. Right. So again taking both m on one side. 3 minus 1. When this 1 will come to the left hand side, it will be negative. This will be equal to 3m plus m. 3 minus 1 is 2. 2 is equal to 4m. So m will be equal to 2 by 4. So m is equal to 1 by 2. When we solve this condition, again when we cross multiply here, it will be 3 minus m is equal to minus 1 into 1 plus 3m. So it will be minus 1 minus 3m. Right? Now when we take the terms of m on one side, then we have 3 minus m plus 3m is equal to minus 1. So minus m plus 3m is equal to minus 1. And when this 3 will go to the right hand side, it will be minus 3. Right? So what is minus m plus 3m? 2m. 2m is equal to minus 4. So m will be equal to minus 4 by 2, which is equal to minus 2. You can see that we have two values of m. Here m is 1 by 2. And for the second case, m is minus 2. Okay, now one thing comes in mind that why we have two values for m. You can see that since we have two tangents, so obviously we will have two slopes. Okay, so that is why we have two values for m. Now, if we talk about this AB, what is AB? AB is the focal chord. And do you know what is the coordinates for the focal chords? The coordinates of focal chords are always in the form of a upon m square, comma, 2a upon m and a upon m square, comma, 2a upon m, right? It means that this is the coordinate of A and this is the coordinate of B. This is the basic thing that you have to remember. Okay, whenever we have a focal chord, then its coordinate will be always in this form. Now let us do one thing. Let us apply m is equal to 1 by 2 for coordinate A, and let us apply m is equal to minus 2 for coordinate B, right? Because the tangents are touching at point A and B, and we know that slopes are for both the tangents. That is why we are substituting one value of m in A and another value of m in B, right? So when we substitute m is equal to 1 by 2 here, we have A upon m square. What will be m square? 1 by 4. So 1 by 4, comma 2a. 2a divided by m. M is 1 by 2, right? So here we have 4a, and here also 2 into 2a will be 4a. When we substitute m is equal to minus 2 here, so a upon minus 2 square will be 4, right? And then when we substitute m is equal to minus 2 here, so 2a upon minus 2, this 2 and 2 will be cancelled, so it will be minus of a. So we have minus a. So the coordinates of a are 4a comma 4a, and the coordinates of b are a by 4 comma minus a. Okay. It is given that point A, B and S are collinear. Okay. So let us write the points. What is point A? Point A is 4a comma 4a. Point B is a by 4 comma minus a, and point S is the focus, so it is a comma 0. It is given that all these 3 points are collinear. Now there is a very basic concept that we need to understand, that when we have 3 different vertices who are collinear, and if they are forming a triangle, then their area of the triangle is always equals to 0. And we have 3 different vertices. Okay, then how can we calculate the area? The basic formula to calculate the area for 3 different vertices is area is equals to determinant of x1, y1, x2, y2, and x3, y3, 1, 1, and 1. This is the basic formula to calculate the area when we have 3 different vertices which are collinear, right? So here, let this point be x1, y1, let this point be x2, y2, and let this point be x3 and y3. So when we substitute its value, so it will be mod of 4a, 4a, 1, a by 4 minus a, 1, and a, 0 and 1. Okay. According to the condition for collinearity, it is given that A, B and S are collinear. It means that its area will be always equal to 0, right? Now what we have to do is we have to expand this determinant with respect to first row. But before expanding, let us simplify this, so it will be easy for us, right? So let us apply one expansion here. Okay, let us apply C1 tends to C1 minus C2. What is C1? Column 1. And what is C2? Column 2. Okay, so C1 tends to means we have to apply the changes in column 1. And what are the changes? C1 minus C2. Let us look at the first terms. 4a minus 4a will be 0. And we have to apply the changes in C1. So first column will be 0. Then a by 4 minus minus a. See, a by 4 minus of minus a will be a by 4 plus a. So when we take the LCM, it will be 5a plus 5a upon 4, right? So this will be 5a upon 4. Remember that we have to apply the changes in column 1. Then last term is a and 0. Okay, this is the term for column 1 and this is the term for column 2. So a minus 0 is a. Remaining terms will remain as it is. So we have 4a minus a, 0, 1, 1 and 1, right? You can see that now it is in a simplified form. And here you can see that the changes are made in the column 1 only because we have applied the changes for column 1, right? So now we have to just expand this with respect to first row. So we have to write the first term, which is 0. Now we have to eliminate first row and first column. So when we eliminate first row and first column, the remaining terms are minus a, 0, 1 and 1. Then with a negative sign, we have to write the second term. What is second term? 4a. Now we have to eliminate first row and second column. So when we eliminate first row and second column, then the remaining terms are 5a upon 4, a, 1 and 1. Okay, these are the terms which are remaining when we have eliminated first row and second column. Now with the positive sign, we have to write the third element. Okay, we are expanding it row wise. So this is the third term in row 1. Okay, now we have to eliminate the first row and the third column. So what are the remaining terms? 5a upon 4 minus a and 0. Now we have to just solve it. And remember, this is equal to 0. So 0 into this whole term will be actually 0. So no need to solve it. Minus 4a. Now how to solve it? We have to multiply both these terms and then we have to subtract product of these terms. It means that 5a upon 4 into 1 minus a into 1. So it is a, right? Plus 1 into 5a upon 4 into 0 will be 0 minus a into minus a. So a into minus a is already minus a square, right? So minus minus will be plus. So we have plus a square and it is equal to what? It is equal to 0. Here you can see that we have minus 4a into 5a upon 4 minus a. So when we solve this whole expression, then we get minus a square. And here we have 1 into 0 will be 0 and 1 into a square will be what? A square. So minus a square plus a square is 0. Here you can see that minus a square plus a square will be also 0. It means that 0 is equal to 0. Now, since we have this expression minus a square plus a square is equal to 0. So, if we put any value of the real number here, it will always satisfy this condition. It will always be equal to 0, right? So, it means that for this question, we can take any value which lies in the real numbers. It means that a belongs to R. Okay, for any value of a, this condition will be satisfied. Okay, because it is minus a square plus a square, it will always be equal to 0, no matter what value we keep here. All right. So for this question, the correct option will be option D, that is any a greater than 0. We can keep any value of a, it will always be satisfied, right? So I hope you are clear with this question. Moving on to the next question. Let a triangle ABC be inscribed in the circle x square minus root 2 into x plus y square is equal to 0 such that angle BAC is equal to pi by 2. If the length of the side AB is root 2, then the area of the triangle ABC is equal to. First of all, it is given in the question that a triangle ABC is inscribed in the circle. It means that the triangle is present inside the circle. And what is the equation of the circle? X square minus root 2 x plus y square is equal to 0. Here we can see that the constant term is 0, right? So one thing is clear that it will pass through the center. Okay. So firstly, let us find the center and the radius for this equation of the circle. The equation is x square minus root 2 into x plus y square. So its center will be 1 upon root 2 and 1 upon root 2. And if we talk about the radius will be 1 unit. All right. It is given that a triangle is present inside this circle and it forms an angle of pi by 2. Angle BAC is pi by 2. Pi by 2 means 90 degree. And length of one side of the triangle is given, which is root 2. We have to find the area of the triangle. So now let us understand the basic diagram for this question. All right. So consider this as the circle for the given question, right? Now, a triangle is inscribed inside this circle. So let us make a triangle. Consider this as the right angle triangle. Why it is right angle? Because it is given that the triangle forms an angle of 90 degree. Okay. So this is the angle of 90 degree. And the name of the angle is BAC. So it will be BAC. All right. Now let us find the coordinates of A, B and C. Okay. One thing is clear that the coordinates of point A is 0, 0. Because the circle and the triangle that is inscribed inside this circle is satisfying a condition such that the point is 0, 0. How it is 0, 0? That firstly, it is passing through the center. This is the center point, right? Let us name it as O. And angle A is 90 degree. It means that it is the angle between the coordinate axis, right? This is the angle that is present between the coordinate axis and the circle is passing through the origin. Therefore, the coordinates of A will be 0, 0. Now about the coordinates of B and C. We have an equation which is x square minus root 2 into x plus y plus y square is equal to 0. So in this equation, if we put x is equal to 0, then we get y is equal to root 2. And similarly, if we put y is equal to 0, then we get x is equal to root 2. Okay. So for B, the coordinates will be root 2 comma 0. And for C, the coordinates will be 0 comma root 2. All right. I hope that this concept is clear to you. Okay. One more thing is given, which is side AB is root 2. So this side is root 2. Okay. And one more thing is used in this question, that is a very basic concept, that if a triangle is inscribed inside a circle and the triangle makes an angle of 90°, then its hypotenuse will be actually the diameter for the circle. Okay, what is the hypotenuse for this triangle? It is BC. So BC is actually the diameter for the circle. Okay, diameter is twice of radius. What is radius? 1 unit. So its diameter will be 2. 1 plus 1 is 2. Okay, so the value of diameter of this circle is 2. We have to find the area of this triangle ABC. All right, we have BC is equal to 2, which is the diameter. We have AB is equal to root 2. Okay. Then we can find AC, okay, by using the Pythagoras theorem. So AC will be equal to root 2. Okay. Since it is a right angle triangle, so we have to use the Pythagoras theorem, which is hypotenuse square is equal to perpendicular square plus base square. So by using that, we get AC is equal to root 2. Now about the area of this triangle. What is the formula for area of the triangle? Area of triangle is equals to half into base into height. Okay. So half into, what is the base? Base is AB. Into height. What is the height? Height is AC. So the area will be half into AB into AC. So 1 by 2 into AB. What is the value of AB? It is root 2. What is the value of AC? It is also root 2. So this will be 1 by 2 into root 2 is 2. So 2 and 2 will be cancelled. So the area of this triangle will be 1. Okay. So for this question, the correct option is option A, that is 1. I hope you are clear with this question. Next question is, let x minus 2 upon 3 is equal to y plus 1 upon minus 2 is equal to z plus 3 upon minus 1 lie on the plane px minus qy plus z is equal to 5 for some p and q belongs to R. The shortest distance of the point from the origin is. It is given that this line lies on the plane px minus qy plus z is equal to 5. So let us first understand what is the standard form to represent a line that lies on a plane. The standard form is x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. Here a, b and c are the direction ratios of the line. The form that is given here is x minus 2 upon 3 is equal to y plus 1 upon minus 2 is equal to z plus 3 upon minus 1. When we compare both these given expressions, we get the value of a, b and c. What is a? A is 3, b is minus 2 and c is minus 1. So a is equal to 3, b is equal to minus 2 and c is equal to minus 1. We also get the value of x1, y1 and z1. What is x1? x1 is 2. So x1 is equal to 2. Now about y1. If we are comparing both this expression, it means that y minus y1 should be equal to y plus 1. So when y minus y1 is equal to y plus 1, y and y will be cancelled. Minus of y1 is equal to 1. So we have y1 is equal to minus 1. Then for z1, again z minus z1 will be equal to z plus 3 since we are comparing the terms, right? So z minus z1 is equal to z plus 3. So z and z will be cancelled. Again minus of z1 is equal to 3. So z1 will be equal to minus of 3. So z1 is equal to minus 3. Here A, B and C are the direction ratios, right? So we have the direction ratios of line, which is 3, minus 2 and minus 1. And we have the points for the line 2, minus 1 and minus 3. It is given that the line lies on the plane. If the line lies on the plane, it means that line is satisfying the plane. It means that the points for the line should also satisfy the plane. What are the points? 2, minus 1 and minus 3. These points are also satisfying the plane, since it is given that the line lies on the plane. So let us do one thing. What is the plane? Plane is px minus qy plus z is equal to 5. If these points are satisfying this equation of plane, then let us put these points. So p into x is 2, y is minus 1 and z is minus 3. So p into 2 is 2p minus q into y. Minus q into y is minus 1, right? So minus q into minus 1 will be plus q plus z. What is z? Minus 3 is equal to 5. So we have 2p plus q is equal to 5 plus 3 is 8. Consider it as equation number 1. Now it is given that the line lies on the plane. It means that the line is parallel to the plane. See, this is the plane and this is the line. You can see that the line is parallel to the plane. It means that this will be the normal to the line. And there is a concept that when a line is parallel to a plane, then the dot product of direction ratios of normal of plane and direction ratios of line will be equal to 0. So we have the direction ratios of line. What is it? 3, minus 2 and minus 1. So the direction ratios of line are 3, minus 2 and minus 1. What are the direction ratios of plane? See, the plane is given px minus qy plus z is equal to 5. The direction ratios are basically coefficient of x, y and z. So it is p minus q and 1. These are the direction ratios of plane. So p minus q and 1. According to the condition, when a line is parallel to the plane, then the dot product of both this should be equal to 0. This is the direction ratio of line and this is the direction ratio of plane. Now let us find the dot product. 3 into p is 3p. Minus 2 into minus q is plus 2q. Minus 1 into 1 is minus 1. It should be equal to 0. So we have 3p plus 2q is equal to 1. Consider it as equation number 2. Now we have two different equations. We can easily find the value of p and q. Let us do one thing. Let us multiply equation 1 with 2. So when we multiply this equation with 2, 2p into 2 is 4p plus 2 into q is 2q is equal to 8 into 2 is 60. Okay. This will be the new equation. And what is second equation? Second equation is 3p plus 2q is equal to 1. Let us do one thing. Let us subtract this equation. Okay. So this will be minus, minus and minus. 4p minus 3p will be p plus 2q and minus 2q will be cancelled is equal to 16 minus 1 is 15. So we have the value of p. What is p? P is 15. Now let us do one thing. Let us put this value of p in equation 1. What is equation 1? 2p plus q is equal to 8. So when we put the value of p here, we will get the value of q. So 2 into p, 2 into 15, since p is 15, plus q is equal to 8. 2 into 15 is 30. 30 plus q is equal to 8. So q will be equal to 8 minus 30. So what is the value of q? Q is minus 22. Now we have the values of p and q. It means that we can substitute these values in the equation of plane. Okay, what is the equation of plane? Equation of plane is px minus qy plus z is equal to 5, right? So it will be px. What is p? 15. 15 into x minus qy. See, minus qy means minus q into y. Okay. So q is minus 22. So minus minus will be plus. So plus 22y plus z is equal to 5. So let us take this 5 on the left hand side. So it will be minus 5 is equal to 0. Now this is the equation which is 15x plus 22y plus z minus 5 is equal to 0. It is in the form of ax plus by plus cz is equal to d, or we can say ax plus by plus cz minus of d is equal to 0, right? So from here we can get the value of a, b, c and d. When we compare both this equation, then a will be equal to 15, b will be equal to 22, c will be equal to 1 and d will be equal to 5. Now we have to find the shortest distance from the origin. Okay. Since origin is mentioned here, so let us first write the formula to calculate the shortest distance from the origin. Do you know what is the formula to calculate the shortest distance from the origin? Distance of a point. Let us consider the point as P, x1, y1 and z1 from the plane ax plus by plus cz is equal to d is always d is equal to mod of ax1 plus by1 plus cz1 minus d divided by under root of a square plus b square plus c square. Since the point is here the origin, okay, we have to find the shortest distance from the origin. Okay, since we have to find the distance from origin, it means that the points p x1 comma y1 comma z1 will be equal to 0. Okay, origin means the 0 comma 0 comma 0, right? So we have the points 0 comma 0 comma 0. It means x1 is 0, y1 is 0, and again z1 is 0, right? So let us substitute the values here. So d will be equal to mod of a. What is a? 15 into x1. x1 is 0. So 15 into 0 is 0. Plus b into y1. 22 into 0 is again 0. Plus c into z1. 1 into 0 is again 0. Minus d. What is d here? 5. So minus of 5. Divided by under root of a square. What is a? 15. 15 square plus b square. 22 square plus c square. So 1 square. So it will be mod of minus 5 divided by under root of 15 square is 225. 22 square is 484 and 1 square is 1. So this will be equal to mod of minus 5 divided by under root of 225 plus 484 plus 1 is 710, right? Since it is mod, so the minus 5 will be equal to plus 5 because of the mod. So we have 5 upon under root of 710. Now let us do one thing. Let us take something out from this under root of 710. So if we take 25 out from under root of 710, then since it is under root, so under root of 25 will be equal to 5. So 5 will come out and what will remain? 5 upon under root of 142. Okay. If we are taking 25 out from here, then 5 will come out and the remaining term from under root of 710 will be under root of 142. Okay. Now 5 into 5 will be actually 25. Okay. So it will be in the whole under root. So we can write it as under root of 5 upon under root of 142. So it is combined value which is under root of 5 upon 142. So this is the required answer for this question. Now let us have a look towards the options. From all the given options, the correct option is under root of 5 upon 142, which is option number B here. I hope you are clear with this question. Next question is the distance of the origin from the centroid of the triangle whose two sides have the equations x minus 2y plus 1 is equal to 0 and 2x minus y minus 1 is equal to 0 and whose orthocenter is 7 by 3 comma 7 by 3 is. In this question, we have to find the distance of the origin from the centroid of the triangle. Origin here means 0 comma 0. We have to find the distance of this origin from the centroid of the triangle. It means firstly we have to find what is the centroid of the triangle, and here two different equations for two sides of the triangle are given and orthocenter is given which is 7 by 3 comma 7 by 3. What is orthocenter? Orthocenter is basically the intersection point of altitudes. Firstly, let us do one thing. Let us make a triangle. So let us consider this as the required triangle. Let us name it A, B, and C. We have two equations for two sides of this triangle. So let us write the equations. X minus 2y plus 1 is equal to 0 and 2x minus y minus 1 is equal to 0. We can see that both are the equations for the sides AB and AC and both the lines are intersecting at a point A, right? So firstly, let us find the intersection point for both the lines. What is the intersection point? A is the intersection point for both the lines and the coordinates of A will be x comma y. So firstly, let us find the coordinates for A. We have two different equations. 2x minus y minus 1 is equal to 0 and x minus 2y plus 1 is equal to 0. Consider it as equation 1 and consider it as equation number 2. Now, let us do one thing. Let us multiply equation second by 2. So when we multiply this equation by 2, then we have 2x minus 4y plus 2 is equal to 0. And what was the first equation? First equation was 2x minus y minus 1 is equal to 0. Now let us add both these equations. This is plus, so it will be minus. This is minus, so it will be plus. And this is plus, so it will be minus. Okay, this is a basic rule that the sign of this elements is changed. All right. Now 2x minus 2x will be 0. Plus 4y minus y will be 3y, right? Plus 3y. Minus 2 minus 1 is minus 3. It is equal to 0. It means that 3y will be equal to 3, right? When 3y is equal to 3, then y will be equal to 3 by 3, which is equal to 1. We have the value of y, which is 1. Now let us do one thing. Let us put this value of y in any of the equations, right? So let us put it in equation number 1. What is equation number 1? 2x minus y minus 1 is equal to 0. So let us put the value of y here. So 2x minus y. What is y? 1. Minus 1 is equal to 0. 2x minus 2 is equal to 0. 2x will be equal to plus 2 and x will be again 2 by 2, which is equal to 1. So we have the coordinates for x and y, which is 1 comma 1. It means that the coordinate of A is 1 comma 1, right? Now it is given that we have to find the distance of the origin from the centroid, right? And the orthocenter is given. As I told you, orthocenter is the intersection point of altitudes. So let us draw two altitudes here. Let us draw a altitude BD on AC, right? So consider this as the altitude BD, and this is perpendicular to AC, right? Now let us make another altitude on AB. So let this be the altitude on AB and let us name this point as E. You can see that here BD is perpendicular to AC and EC is perpendicular to AB, and here E and D are the foot of the perpendiculars. So it will be 90 degree, right? And what is the intersection point of both these altitudes? This is the intersection point, right? It means that this is the orthocenter, right? Let us name it as H. And what are the coordinates of orthocenter? The coordinates for orthocenter are 7 by 3 and 7 by 3, right? Now you can see that here we have two different conditions. What are the conditions? BD is perpendicular to AC and EC is perpendicular to AB. If BD is perpendicular to AC, it means that slope of BD multiplied by slope of AC will be equal to minus 1. We know that if we have a condition which is BD is perpendicular to AC, then the product of slopes of BD and AC will be equal to minus 1, right? So let us first find the slopes. If we talk about the slopes of both the lines, all right, what is the slope of AB? We have the equation of the line here, which is 2x minus y minus 1 is equal to 0. And we know that the standard form is y is equal to mx plus c, right? So let us transform this equation in this form. Okay. So we have 2x minus y minus 1 is equal to 0. So it can be written as 2x minus 1 is equal to y. Okay. This is in the form of y is equal to mx plus c. So y will be equal to 2x minus 1. Now, if we compare both these equations, then the value of m is 2. And what is m? M is the slope. So we can say that the slope of line AB is 2, right? Similarly, if we talk about AC, the equation for AC is x minus 2y plus 1 is equal to 0. And the standard form is again y is equal to mx plus c. So let us convert this equation in this form. We have x minus 2y plus 1 is equal to 0, right? So it can be written as x plus 1 is equal to 2y. But we want y on one side. So let us do one thing. Let us take this 2 on the another side. So we have x by 2 plus 1 by 2 is equal to y. Okay, now it is in the form of y is equal to mx plus c. What is m? M is the coefficient of x. Here you can see that the coefficient of x is 1 by 2. So here the value of m will be 1 by 2. Okay, this is the slope for side AC. So we can write slope of AC is 1 by 2. All right. Now we have to find the slope for both the altitudes. Okay, since BD is perpendicular to AC, it means that the product of slope of BD and AC will be equal to -1. So firstly, let us find the slope for BD. You can see that we don't have the coordinates of B and C here. All right. So let us do one thing. Let us first assume the coordinate of B and C. Okay. If we are assuming the x coordinate of B as alpha, then what will be y coordinate? C. We have the equation 2x minus y minus 1 is equal to 0, right? So if we assume the value of x is equal to alpha here, we have 2 alpha minus y minus 1 is equal to 0. So 2 alpha minus 1 will be equal to y, means the value of y will be 2 alpha minus 1, right? And similarly, if we talk about this point C, if we consider the y coordinate of point C as beta, what is the equation here? The equation is x minus 2y plus 1 is equal to 0. If we consider y is equal to beta here, then what will be the value of x? Let us check. X minus 2 into y, 2 into beta plus 1 is equal to 0. So x will be equal to 1 minus 2 beta, right? 1 plus 2 beta. See, this minus 2 beta will go to the right hand side. So it will be plus. And when this plus 1 will go to the right hand side, it will be minus. So we can write it as 2 beta minus 1. So x is equal to 2 beta minus 1. So when y is equal to beta, then x will be 2 beta minus 1. So these are the coordinates for B and C. Now how to find the altitude for BD? You can see that in the altitude here, which is BD, we have the points or the coordinates for B, and we have the orthocenter. You can see this orthocenter lies on BD also, right? So we can do one thing. We can find the slope by considering these points as x1, y1 and x2, y2. Okay, for the altitude BD, we have 2 points, alpha and 2 alpha minus 1, and the orthocenter, which is 7 by 3 and 7 by 3. These are the points for BD. And we know that the basic formula to calculate the slope is y2 minus y1 upon x2 minus x1, right? So this is the basic formula. So let us consider this is x1, y1 and x2, y2. So the slope will be y2 minus y1. What is y2? 7 by 3 minus y1, 2 alpha minus 1 divided by x2 minus x1. 7 by 3 minus x1 is alpha, right? So this is the slope for BD. So we can say that this is the slope for BD, right? Now, if we further solve it, this will be equal to, if we take the LCM, LCM will be 3 in the numerator part, and in the numerator part we have 7 minus this minus 2 alpha, minus into 2 alpha will be minus 2 alpha, and 3 into 2 is 6. So minus 6 alpha. Minus minus will be plus 1. So 3 into 1 will be plus 3. Divided by, when we take the LCM for this part, LCM will be 3. And the numerator will be 7 minus 3 into alpha is 3 alpha, right? So this 3 and 3 will be cancelled. So we have 7 plus 3 is 10. 10 minus 6 alpha divided by 7 minus 3 alpha, right? So this is the value for the slope of BD, right? Now let us find the slope of another altitude. What is another altitude? Another altitude is EC. On the altitude EC, you can see that we have the coordinates for C, and again we have the orthocenter here. This H also lies on EC, right? So by using both these points, we can find the slope for EC. So let us see, for EC we have 2 coordinates. The coordinates of C, what are the coordinates of C? 2 beta minus 1 and beta, and we have the orthocenter, which is 7 by 3 comma 7 by 3. Again consider it as x1, y1 and x2, y2. So slope for EC will be equal to y2 minus y1 divided by x2 minus x1. What is y2? 7 by 3 minus y1. What is y1? Beta divided by x2 minus x1. 7 by 3 minus x1. 2 beta minus 1. Now when we further solve this, in the numerator part the LCM will be 3, and again the numerator will be 7 minus 3 beta. divided by, in the denominator part, the LCM will be 3. And here the numerator will be 7 minus 2 beta. Okay. When we open this brackets, we have minus 2 beta and minus minus plus 1. So 3 into minus 2 beta is minus 6 beta. Again, minus minus will be plus 1. So 3 into 1 is plus 3. This 3 and 3 will be cancelled. So we have 7 minus 3 beta divided by 7 plus 3 is 10. 10 minus 6 beta. This is the value for slope of EC. As we know that we have to use the concept here. If BD is perpendicular to AC, it means that their product of the slope will be equal to minus 1. It means product of BD and AC will be equal to minus 1. So we can write that since BD is perpendicular to AC, it means that slope of BD into slope of AC will be equal to minus 1, right? It means that the product of their slopes will be equal to minus 1. Now, what is slope for BD? It is 10 minus 6 alpha upon 7 minus 3 alpha. So 10 minus 6 alpha upon 7 minus 3 alpha multiplied by slope for AC. What is the slope of AC? Slope of AC is 1 by 2. So multiplied by 1 by 2. It is equal to minus 1. Now let us multiply it. 10 minus 6 alpha into 1 will be 10 minus 6 alpha divided by 7 minus 3 alpha into 2. 7 into 2 is 14. Minus 3 alpha into 2 is minus 6 alpha. This is equal to minus 1. Now let us cross multiply. So when we cross multiply, here we have 1. So 10 minus 6 alpha into 1 will be 10 minus 6 alpha. Now 14 minus 6 alpha into minus 1. So 14 into minus 1 is minus 14. Minus 6 alpha into minus 1 is plus 6 alpha, right? Now let us do one thing. Let us take the terms of alpha on one side and let us take the numbers on another side. So we have 10 plus 14 is equal to 6 alpha plus 6 alpha. 10 plus 14 is 28, right? So 28 will be equal to 12 alpha. 6 plus 6 is 12. No, this will be 24, right? 10 plus 14. It is 24. So here alpha will be equal to 24 by 12. 24 by 12 is 2. So the value of alpha is 2, right? Again, we have another condition, which is the altitude EC is perpendicular to AB, right? So we can write that since EC is perpendicular to AB, it means that the product of their slopes will be equal to minus 1. So slope of EC multiplied by slope of AB will be equal to minus 1. What is slope of EC? Slope of EC is 7 minus 3 beta upon 10 minus 6 beta. So 7 minus 3 beta upon 10 minus 6 beta multiplied by slope of AB. What is the slope of AB? We have the slope of AB as 2. So multiplied by 2 is equal to minus 1. Here the denominator is 1. Now let us multiply it. 7 minus 3 beta into 2. It is 14 minus 6 beta divided by 10 minus 6 beta. It is equal to minus 1. So when we cross multiply, we have 14 minus 6 beta is equal to 10 into minus 1 is minus 10. Minus 6 beta into minus 1 is plus 6 beta, right? Now let us do one thing. Let us take the numbers on one side and the terms for beta on another side. So 14 plus 10 is equal to 6 beta plus 6 beta. Again 14 plus 10 is 24. So 24 will be equal to 12 beta. Again beta will be equal to 24 by 12. So the value of beta is also 2, right? So now we have the value of alpha and beta. Alpha is equal to 2 and beta is equal to 2. Since we have the value of alpha and beta, we can find the actual coordinates for B and C. You can see that the coordinates of B and C are in the terms of alpha and beta. Since we have the value of alpha and beta, so we can find the actual value of these coordinates, right? So let us first write the coordinates of B. What are the coordinates of B? The coordinates of B are alpha and 2 alpha minus 1. And the coordinates of C are 2 beta minus 1 and beta, right? Now let us put the values of alpha and beta here. So B coordinates will be alpha. What is alpha? 2. Comma 2 into alpha minus 1 means 2 into 2 minus 1. 2 into 2 is 4. 4 minus 1 is 3. So these are the actual coordinates for B. When we talk about the coordinates of C, we have 2 into beta minus 1. So what is beta 2? 2 into 2 minus 1 will be again 3. 2 into 2 is 4 and 4 minus 1 is 3, comma beta. What is the value of beta? 2. So these are the coordinates for C, right? Now we have the coordinates of A, B and C. What is the coordinate of A? The coordinate of A is 1, comma 1, right? The coordinate of B is 2, comma 3 and the coordinate of C is 3, comma 2. All right. In order to find the centroid of the triangle, we have to use a formula. Centroid of a triangle is always equals to x1 plus x2 plus x3 upon 2, y1 plus y2 plus y3 upon 3. Okay, here we have three terms. That is why it will be divided by 3. Now, what is x1, x2, x3 and y1, y2, y3? Let us consider these points as x1, x2 and x3 and y1, y2 and y3, right? So let us consider this is x1, y1, x2, y2 and x3, y3. So centroid will be x1 plus x2 plus x3, 1 plus 2 plus 3 divided by 3. Then y1 plus y2 plus y3, 1 plus 3 plus 2 divided by 3. So here we have 1 plus 2 plus 3 is 6, 6 by 3 is 2. Again 1 plus 3 plus 2 is 6, 6 by 3 is 2. So this is the centroid of the triangle. Now we want to find the distance of the origin from this centroid. Okay, as I told you, origin means 0, 0. We have to find the distance of this origin from this centroid. So this is the origin and 2, 2 is the centroid. Now how we can find the distance between 2 points? We have to use the distance formula. Do you know what is the distance formula? Distance formula for 2 points is under root of x2 minus x1 square plus y2 minus y1 square, right? So let us consider this as x1, y1 and x2, y2. So when we substitute the values here, we have under root of x2 minus x1, 2 minus 0 square plus y2 minus y1, again 2 minus 0 square. So this will be under root of 2 square plus 2 square. What is 2 square? 4. So 4 plus 4. So we have under root of 8. This under root of 8 can be also written as 2 root 2, right? How 2 root 2? Let us take the LCM of 8. So we have 2, 4, then 2, 2, then 2 and 1. So what is the LCM? One pair will come out, 2. And what is remaining? Under root 2. So this is the LCM, right? It means that 8 can be written as 2 root 2. Means under root of 8 can be actually equal to 2 root 2, right? So for this question, the correct answer will be 2 root 2, which is option C here. I hope you are clear with this question. Next question is, let Q be the mirror image of the point P 1, 2, 1 with respect to the plane x plus 2y plus 2z is equal to 16. Let T be a plane passing through the point Q and contains the line r vector is equal to minus k cap plus lambda into I cap plus j cap plus 2k cap, where lambda belongs to r. Then which of the following points lies on T? We have to find the points that lies on T. What is T? T is a plane that is passing through the point Q and it contains the line r vector. And it is given that Q is the mirror image of the point P with respect to the plane x plus 2y plus 2z is equal to 16. It means that firstly we have to find the equation of T. Okay, then only we can find that which points lies on T. It means we have to basically find the equation of the plane T. And to find the equation of plane T, we need the point Q and we need the points which contains the line r vector, right? So firstly, let us have a look towards the first statement. It is given that Q is the mirror image of point P with respect to a plane. So let us consider a plane. Let this be the plane. We have a point P. If Q is the mirror image of point P, it will be exactly opposite, right? So this is Q. You can see that here Q is the mirror image of point P. What is point P? 1, 2, 1. If Q is the mirror image, it will be exactly in the opposite direction. That is why Q is here. Now, how to find the coordinates of Q? Firstly, let the coordinates of Q be alpha, beta, and gamma, right? It is given that P lies on respect to this plane. What is the plane? X plus 2y plus 2z is equal to 16. All right. Now, if we talk about the direction ratios of this plane, it will be equal to the direction ratios of the normal. Okay. If this is the midpoint here for PQ, let us consider the midpoint as M, right? And if we talk about the normal of this point P, right, then its direction ratio will be equal to the direction ratio of the plane. And what are the direction ratios of plane? It will be 1, 2, and 2. Okay. How to find the direction ratio of plane when an equation of plane is given? We have to just find the coefficient of x, y, and z. So the direction ratio of this line PQ is 1, comma 2, comma 2. All right. Now we have to find the midpoint first in order to find the coordinates for Q. Now how we will find the midpoint? We will use the formula which is x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. Here a, b, and c are the direction ratios. Okay. And what is x1, y1, and z1? So basically x1, y1, and z1 are the values which is 1, 2, and 1. All right. Which is the point P. This is the values for x1, y1, and z1. So it will be x minus x1. What is x1? 1 upon a. A, b, and c are the direction ratios. What are the direction ratios of line? 1, 2, and 2. It means this is a, b, and c. So we have a. So 1. It is equal to y minus y1. What is y1? 2. Divided by b. The value of b is 2. It is equal to z minus z1. What is z1 here? Z1 is 1. So minus 1 divided by C. C is again 2. Okay. Now to find the values of x, y, and z. Firstly, let us consider this whole expression equal to k. Right. So we can easily find the coordinates. So what will be coordinates? We have to separately equate all these terms with k. So when x minus 1 divided by 1 is equal to k, then x minus 1 will be equal to k. Right. So x will be equal to k plus 1. Similarly, when y minus 2 upon 2 will be equals to k, then after cross multiplying, we have y minus 2 is equal to 2k. So y will be equals to 2 plus 2k. Similarly, when the last part z minus 1 upon 2 will be equals to k. So z minus 1 will be equals to 2k on cross multiplying, right? So z will be equals to 1 plus 2k. So we have the coordinates of x, y, and z in terms of k. What are the coordinates? The coordinates are k plus 1, which is the value of x, 2 plus 2k, the value of y, and 1 plus 2k, the value of z. Now, these are the coordinates of the midpoint. Okay, it means that these are the coordinates of M, right? Now, you can see that this is the midpoint of the line PQ. Okay, if we talk about PQ, then it is basically a line that is passing through this plane, right? Then M is the midpoint of the line PQ, right? And we have the plane which is x plus 2y plus 2z minus 16 is equal to 0. Okay. This can be written as x plus 2y plus 2z minus 16 is equal to 0. Right. So if M is the midpoint of PQ and we have the coordinates of M, then it should satisfy the plane. Okay. Since the line PQ is passing through the plane, it means that the point M will also satisfy this equation of plane. Okay. So in order to prove that this point M satisfies this equation, we have to substitute the value of x, y, and z here, right? I hope the concept is clear to you. This line PQ is basically passing through the point. Okay. It is passing through the plane here. And since it is passing through the plane, then it is satisfying the equation of plane. That is why the midpoint of this line will also satisfy the equation of the plane. All right. So what is the equation of the plane? The equation of plane is x plus 2y plus 2z minus 16 is equal to 0. So let us do one thing. Let us substitute the values of x, y, and z here. All right. What is x? K plus 1 plus 2y. 2 into y is 2 plus 2k plus 2z means 2 into z. So what is the value of z? 1 plus 2k. Minus 16 will be equal to 0. Now we have to simply solve it. So k plus 1 plus 2 into 2 is 4 plus 2 into 2k is 4k, plus 2 into 1 is again 2, plus 2 into 2k will be 4k, minus 16 is equal to 0, right? Now adding the terms of k plus 4k plus 4k. 4 plus 4 is 8, 8 plus 1 is 9, so 9k. 1 plus 4, 5, 5 plus 2, 7. 7 minus 16, right? So plus 7 minus 16 is equal to 0, right? So this will be 9k plus 7 minus 16. What is 7 minus 16? It is minus 9. This is equal to 0. So 9k will be equal to 9 and k will be equal to 1. Now we have the value of k. So we can find the actual coordinates of point n, right? What is the coordinates? K plus 1, 2 plus 2k and 1 plus 2k. Since k is 1, so the coordinates will be k plus 1. 1 plus 1 is 2. 2 plus 2k means 2 plus 2 into 1. So 2 plus 2 is 4. Then 1 plus 2k, 1 plus 2 into 1, it is 3. Okay. So the coordinates of point M are 2, 4, 3, which is the midpoint. You can see that M is the midpoint of PQ, right? Now we have the midpoint, which is 2, 4, 3, and we have the point P. So by using the midpoint theorem, we can easily find the coordinates of Q. Okay, the coordinates of Q will be 3, 6, and 5. We have used the midpoint theorem to find the coordinates of Q here. Now, we just have to find the equation of plane T. You can see that we have point Q, right? We have the point that is passing through the plane, okay? And there is a very basic concept that if T is passing through point Q and Q is the mirror image of point P, okay? And T also contains the line which is R vector. All right, then it means that there is a common point which is passing through the plane and it is passing through the line also, right? So to find the equation of plane T, we need three different things, right? Firstly, we need the coordinates of Q. Then we need the coordinates of all the vectors that are present in this equation of line. Here, what is R vector? R vector is basically A vector plus lambda into B vector, all right? So you can see that for A vector, only k cap is given, means the terms of I and j is 0 here. So the coordinates will be 0, 0, minus 1. Okay, why minus 1? Because we have minus k. The coefficient of k is minus 1, right? And if we talk about B vector here, the coordinates will be 1, 1, 2. Okay, coordinate of I, j, and k. It means that the coefficient of I, j, and k. What is the coefficient of I? 1. What is the coefficient of j? 1. And what is the coefficient of k? 2. Right? So we have to find the equation of plane T. What is the basic formula to find the equation here? Whenever we have to find the equation of plane, then we use a formula mod of x minus x1, y minus y1, and z minus z1. Okay. And it is in the form of determinant, and this will be always equal to 0. And the remaining two rows will contain the coordinates for point Q and the coordinate for B vectors, right? So what is x minus x1? Firstly, we have a point which is 0, 0, minus 1. Let this point be R, right? So if we want x minus x1, so let us consider x1, y1, and z1. So x minus 0 is x, right? Then y minus 0 is y. Z minus z1. Z1 is minus 1. So z minus minus 1 will be z plus 1, right? So now we want two more rows which will consist of point Q. What is point Q? Point Q is 3, 6, 5, right? Now, another point will be the point for B vector. What is the point that we have found? 1, 1, 2. So this will be another point. Let this point be S. So 1, 1, 2, right? Now we have to do one thing here. Since R also lies on the plane and point Q also lies on the plane. Okay, plane is passing through point Q. It means that we have to find its direction ratio. Okay, so direction ratios will be 3 minus 0, 3, 6 minus 0, 6, and 5 minus minus 1 will be 5 plus 1. So it will be 6. So we have 3, 6, and 6. And what are the other points? 1, 1, and 2, right? Now we have to simply expand this determinant with first row. Okay, means we have to expand the determinant along first row, right? So let us expand it. What is the basic form to expand this determinant? We have to write the first element of first row, then we have to eliminate first row and first column. So after eliminating first row and first column, the remaining terms are 6, 1, 6 and 2. Then with a negative sign, we have to write the second element of first row. Now we have to eliminate first row and second column. So when we eliminate the first row and second column, the remaining terms are 3, 6, 1 and 2. Then with a positive sign, we have to write the third term. What is third term? Z plus 1. And now we have to eliminate the first row and third column. So when we eliminate the first row and third column, the remaining terms are 3, 6, 1 and 1. This is equal to 0. See why we are equating it with 0? Because whenever we have to find the equation of a plane, then we always equate the determinant with 0, right? So this will be x into. We have to cross multiply 6 into 2 minus 1 into 6. What is 6 into 2? 12. Minus 1 into 6 is 6. Minus y into 3 into 2, 6. Minus 1 into 6, 6. Right? Plus z plus 1 into 3 into 1, 3, minus 1 into 6 is 6. It is equal to 0. So x into 12 minus 6 is 6. So 6 into x is 6x minus y into 0. 6 minus 6 will be 0. So the term for y will be 0. Now plus z plus 1 into 3 minus 6. What is 3 minus 6? It is minus 3. So z plus 1 into minus 3. Okay. Minus 3 into z is minus 3z. Then 1 into minus 3 is minus 3. It will be equals to 0, right? So we have 6x minus 3z minus 3 is equal to 0, right? Because 3 minus 6 is minus 3. Minus 3 into z is minus 3z and minus 3 into 1 is minus 3, right? So we can take 3 common. So it will be 2x minus z minus 1 is equal to 0, right? So we have 2x minus z is equal to 1. So this is the equation that is formed after expanding the determinant. Okay, this is the equation of plane T. We have to find the points that lies on plane T. Okay, so since we have the equation now, we just have to try all the given options. What is the equation of plane? The equation of plane is 2x minus z is equal to 1. Now what we have to do is we have to hit and try all the options here. Okay, when we hit and try all the options, we find that option B, which is 1 comma 2 comma 1, lies on this plane, right? So this is the correct option. I hope you are clear with this option. So the correct option is option B here. Okay, after finding the equation of plane, all you have to do is you have to hit and try all the options and you will easily find that which option satisfies or lies on point T. Okay, lies on the equation of T. So I hope you are clear with this question. Next question is, let A, B and C be 3 points whose position vectors respectively are A vector, B vector and C vector. If alpha is the smallest positive integer for which A vector, B vector and C vector are non-collinear, then the length of the median in triangle ABC through A is. This is a very, very interesting question. In this, 3 different position vectors are given and A, B and C are the 3 points whose position vectors are A vector, B vector and C vector. It means that for point A, the vector is A vector. For point B, the position vector is B vector. And for point C, the position vector is C vector. And you can see that in B vector, we have a term which is alpha. And alpha belongs to R. We have to find the smallest possible value for this integer for which A vector, B vector and C vector are non-collinear. It means we have to find the smallest positive value for alpha such that all these position vectors should be non-collinear. Then we have to find the length of the median in triangle ABC through A. Okay, so firstly, let us make a triangle to understand the concept. Consider this as the required triangle ABC. We want to find the length of the median in triangle ABC through vertex A. Okay, so through A, let us make a median. Let the M. Okay, let it be M. Now we have to find the length of this median. It means we have to find AM, basically the distance between A and M. All right. And you can see that here three different vectors are given, A, B, and C, which are the position vectors of 3 points A, B, and C. Okay. Basically, the position vector is in the form of xi cap plus yj cap plus zk cap. So considering point A, for point A, the position vector is A vector, right? So here the values of x, y, and z will be coefficient of I, j, and k. So the values will be 1, 4, and 3. Similarly, considering point B, for point B, the values of x, y, and z will be 2, alpha, and 4. So we have 2, alpha, and 4. And for point C, we will have the values of x, y, and z as 3, minus 2, and 5. So 3, minus 2, and 5, right? Since it is given that A, B, and C are the 3 points whose position vector is this given vectors. That is why point A will be 1, 4, 3, point B will be 2, alpha, 4, and point C will be 3, minus 2, and 5. Okay. Now let us do one thing. Let us find the direction ratios of AB. How to find the direction ratios of AB? It is very simple. 2 minus 1, 1. Alpha minus 4, alpha minus 4, and 4 minus 3, again 1. Now let us find the direction ratios of AC. So for AC, we have to consider coordinates of A and coordinates of C. So 3 minus 1, 2, minus 2, minus 4, minus 6, and 5 minus 3, 2. So these are the direction ratios of AB and these are the direction ratios of AC. We have to find the smallest value of alpha for which A vector, B vector, and C vector are non-collinear. So let us do one thing. Let us find the value of alpha for which all these vectors are collinear first. All right. Then we will find the value of alpha for which all these vectors are non-collinear. But first, let us find the value for alpha for which these vectors are collinear. Now let us do one more thing. Let us make AB parallel to AC. All right. If AB will be parallel to AC, then its direction ratios will be also equal. Okay, what are the ratios here? 1 by 2, alpha minus 4 by minus 6, and 1 by 2. It means that if AB vector is parallel to AC vector, okay, we are just assuming this, that AB vector is parallel to AC vector just to get the value of alpha, which is collinear, right? So if AB vector is parallel to AC vector, then in this case, 1 by 2 will be equal to alpha minus 4 upon minus 6 will be equal to 1 by 2, right? If two vectors are parallel, then their direction ratios are also in the form of ratio and they are equal. So by taking two terms, 1 by 2 is equal to alpha minus 4 upon minus 6. On cross multiplying, we will have minus 6 is equal to 2 into alpha is 2 alpha minus 4 into 2 is minus 8, right? So minus 6 plus 8 will be equals to 2 alpha. What is minus 6 plus 8? It is 2. So 2 is equal to 2 alpha. So in this case, we will have alpha is equal to 1. So the value of alpha is equal to 1 for a condition which is A vector, B vector, and C vector are collinear, right? We have assumed that AB vector is parallel to AC vector just to get the value of alpha for a condition that A, B, and C vectors will be collinear, okay? Remember that we have to find the smallest value, okay, for which A, B, and C are non-collinear. And now we have the value for which A, B, and C are collinear, okay? So the next smallest value will be 2. It means that at alpha is equal to 2, A vector, B vector, and C vector are non-collinear. Since we know that at alpha is equal to 1, these factors are collinear. So the next possible value is 2, and it is the smallest value for alpha for which A, B, and C will be non-collinear. So we can say that A vector, B vector, and C vector are non-collinear if alpha is equal to 2, which is the smallest possible integer. Okay, so we have the value of alpha now. So we can easily find the coordinates for B. What are the coordinates of B? Coordinates of B were 2, alpha, and 4. Okay. So coordinates of B were 2, alpha, and 4. We know the value of alpha. So coordinates of B will be 2, comma 2, comma 4. All right. And we have the coordinates of C, which is 3, -2 and 5. All right. You can see that we have already found out the coordinates of C, which is 3, -2 and 5. What is BC? BC will be the base of the triangle. See, BC is the base of the triangle. And if through vertex a median is made, which is AM, then M will be the midpoint of BC, right? In order to find the length of AM, we want to get the coordinates of M. It means that we want the midpoint for BC. So let us find the midpoint for BC. We have the coordinates of BS 2, 2, 4 and the coordinates of CR 3, -2 and 5. All right. So what will be the midpoint? Midpoint of BC will be equal to 3 plus 2 by 2. So 5 by 2. Then -2 plus 2 by 2. So -2 plus 2 is 0. 0 by 2. Then 5 plus 4 by 2. What is 5 plus 4? 9. 9 by 2. So the midpoint is 5 by 2, 0, 9 by 2. The formula for midpoint is just x1 plus x2 upon 2, then y1 plus y2 upon 2, then z1 plus z2 upon 2, right? So in this way, 3 plus 2 upon 2 is 5 by 2, -2 plus 2 upon 2 is 0 by 2, and 5 plus 4 upon 2 is 9 by 2. So this is the midpoint of BC. It means that these are the coordinates of point M, okay? And what are the coordinates of point A? We know that the coordinates of point A are 1, 4, 3. We have already written it. The coordinates of point A is 1, 4, 3. And now we have the coordinates of M. So we can easily find the distance, which is AM, right? What are the coordinates of M? The coordinates of M are 5 by 2, 0 and 9 by 2. Now we have to find the distance AM. How we can find the distance between 2 points? We have to use the distance formula here. What is the distance formula? Distance formula is equal to under root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. All right. When we have the coordinates in terms of 3, x, y, and z, then this is the distance formula. All right. So now we have to use this formula, which is under root of x2 minus x1 square plus under root of y2 minus y1 square plus z2 minus z1 square. Okay. So now let us consider these points as x1, y1 and z1 and x2, y2 and z2, right? So we want to perform x2 minus x1, okay? So here it will be 5 by 2 minus 1, all right? So it will be under root of 5 by 2 minus 1 whole square. Now what is 5 by 2 minus 1? Let us take the LCM. LCM will be 2. Okay. So numerator will be 5 minus 2. So it is 3 by 2 plus y2 minus y1. What is y2? 0. Minus y1 is 4 whole square plus z2 minus z1. 9 by 2 minus 1 whole square. Now what is 9 by 2 minus 1? Let us find it. 9 by 2 minus 1. Again the LCM will be 2. See, 9 by 2 minus 3. Z1 is 3, not 1, right? What is the value of Z1? Z1 is 3. So 9 by 2 minus 3. Now the numerator will be 9 minus 2 into 3 is 6. What is 9 minus 6? 3. 3 by 2. So its value will be under root of 3 by 2 square plus 0 minus 4 is minus 4 square plus 9 by 2 minus 3 is again 3 by 2 square. So this will be equal to 3 by 2 square. What is the square of 3? 9. What is the square of 2? 4. Plus minus 4 square. Minus 4 into minus 4 is plus 16. Plus 3 by 2 square will be 9 by 4. Now we have to take the LCM here. All right. When we take the LCM, you can see that here the denominator is 1. So LCM will be 4. Now the numerator will be 9 plus 16 into 4 is 64 plus 9. When we add all these values, 9 plus 64 plus 9, it is equal to 82. 82 divided by 4. Now we know that root 4 is basically equal to 2. So we can take this root 4 outside. When it will come out, then we get 2, right? So we have under root of 82 divided by 2. This is the length of the median that is made through vertex A. What is the median? AM. So this is basically the distance or the length of the median AM. And for this question, the correct answer is under root of 82 upon 2. So I hope you are clear with this question. And the correct option here is option A. Next question is the probability that a relation R from x comma y to x comma y is both symmetric and transitive is equal to. In this question, we have to find the probability for a relation R that goes from this set to this set. And we have to identify it in such a way that both should be symmetric and transitive. Okay. So let us consider this as set A and let us consider this as set B. So we have set A is x comma y and set B is x comma y. Now let us calculate the Cartesian product of both these given sets. Okay. What is Cartesian product? In simple words, it is basically the product of two sets A and B, which is denoted by A cross B. And it is the set of all the ordered pairs where the first element lies in A and the second element lies in B. Okay. So let us find the ordered pairs. First element will be of A and second element will be of B. It simply means x comma x. Then next ordered pair will be x comma y, then y comma x, and then y comma y. I hope you are clear with this. First we have to take x with x, then x with y, then y with x and y with y. So in this way we found the Cartesian product of two given set. Now this is the Cartesian product which consists of four ordered pairs, right? Now let us calculate the total number of relations. So if we want to calculate the total number of relations here, how we will calculate it? There is a basic formula to calculate the total number of relations, which is 2 power m into n. Now, what is m and what is n? M is the number of elements in the first set. What is the first set? It is set A. And n is the number of elements in the second set. What is second set? It is set B. All right. So the total number of relations will be 2 power m into n. So it will be 2 power m. What is m? M is the number of elements in set A. In set A, we have two elements. So m is 2. Similarly, n is the number of elements in set B. In set B, we have two elements. So it will be 2. So 2 power 2 into 2. 2 power 4. What is 2 power 4? 2 power 4 is 16. All right. So this is the total number of relations. Or we can say that this is the sample space. Since we have to calculate the probability here, so the sample space is 16. Okay. Now what we have to do is we have to find all the relations which are symmetric as well as transitive. But before that, let us understand what is a symmetric relation and what is a transitive relation. All right. So a relation is symmetric if A comma B belongs to R and B comma A also belongs to R. Similarly, a relation is transitive if A comma B belongs to R. It implies B comma A belongs to R. It implies A comma C should also belongs to R. All right. So this is the basic concept behind a symmetric relation and transitive relation. But first, let us define the relation that consists of all the ordered pairs which are symmetric and transitive. So let us define it by R. So the first element will be phi. It is very obvious that phi is the element that satisfies all the condition. Okay. Now, if we talk about the single ordered pairs, okay, single ordered pair means the pair which consists the same elements like x comma x and y comma y. So if we talk about the single ordered pairs, then these are also symmetric as well as transitive. Okay, let us consider x comma x as A comma B. So for symmetric, AB belongs to R and BA also belongs to R. What is BA? BA will be x comma x only. So it is symmetric. Now for transitive, okay, AB and BA already belongs to R. So CA. Now C will be also x only here. Okay, so it will be transitive 2. Now, if we talk about the double ordered pairs, okay, what will be the double ordered pairs? They will be the pairs which have same elements but they are together. Okay, this whole set is a single set. So if we talk about this set, you can see that it is also symmetric as well as transitive. Okay, here AB and BA belongs to R and also AC belongs to R, right? Now, see, the first condition is for phi, second condition is for the single ordered pairs. Third condition is for the double ordered pairs. Okay, so what is the last condition that is remaining? Last condition is if we take all the elements. What are all the elements? All the elements are x comma x, x comma y comma x, and y comma y. So if we take this all elements, then also it is symmetric and transitive. Okay, this is the first element, this is second element, okay, this is third, and this is fourth, and this last element is fifth element. So if we consider this fifth element, you can see that here a comma b belongs to R and b comma a also belongs to R. Okay, if we talk about transitive, here a comma b, let us take this as a and let us take this as b. Okay, so here a comma b belongs to R and b comma a also belongs to R. Okay, so a comma c should also belongs to R. Now what is a comma c? It is x comma x. Okay, so it is transitive. So we can say that for all this set, the relation R is symmetric as well as transitive, but we have to identify the total number of set here. Okay, so what are the total number of set which are symmetric and transitive? Let us count them. First set is phi, second set is x comma x, third set is y comma y, fourth set is x comma x and y comma y, and the fifth set is the large set which consists of all the elements. So we have total 5 set. Okay, so now we have to calculate the required probability. So probability will be the total number of set which are symmetric and transitive, which is 5, divided by the total sample space. What is the sample space? We have already calculated it. Sample space is 16. So the probability is 5 by 16. So for this question, the correct answer is 5 by 16, and hence the correct option is option A here. Next question is the number of values of A belongs to N such that the variance of 3, 7, 12, A, 43 minus A is a natural number is. So we have to find the variance of this given terms. What is the basic formula to calculate the variance? Variance is equals to summation of xi square upon n minus mean square. It means that to calculate the variance, we first need to calculate the mean. What is mean? Mean is basically sum of all the observations upon total number of observations. This is the basic formula to calculate mean. What are the observations here? The observations are 3, 7, 12, A and 14, 3 minus A. Okay, so let us add all these values because mean is sum of all the observations. So 3 plus 7 plus 12 plus A plus 43 minus A. 43 minus A is a single term here, right? Divided by total number of observation. What is total number of observation? 1, 2, 3, 4 and 5. So divided by 5. Now let us add these values. 3 plus 7 is 10. 10 plus 12 is 22, right? 22 plus 43 will be 65. And this plus A and minus A will be cancelled. So 65 by 5 is equal to 13. So we can say that mean is equal to 13. Mean is also denoted as x bar. So x bar is equal to 13. And basically what is mean? It is actually the sum of all the observations upon total number of observations. So it can be also denoted as summation of xi. What is xi? Xi is the sum of all the values. Okay, xi is this terms 3, 7, 12 and so on. Summation of xi means summation of all these terms. divided by total number of observations. Total number of observations is n. So mean is denoted in this way too. Now let us calculate the variance. What is the variance? Variance is summation of xi square, means the square of all these values, means the sum of square of all these numbers. What are the numbers? 3. So what is 3 square? 9. Plus 7. What is 7 square? 49. Right? Plus 12 square, 144. Plus a square and plus 43 minus a square. Right? This is summation of xi. See, what is xi? Xi is all these values. So summation of xi square will be what? 3 square plus 7 square plus 12 square plus a square plus 43 minus a square, right? This is summation of xi square. And if we talk about summation of xi, it means 3 plus 7 plus 12 plus a plus 43 minus a. Okay, this is the basic sum and this is the square of the sum. So when we do the square, 3 square is 9, 7 square is 49, 12 square is 144, a square is a square, and 43 minus a whole square divided by. Now, what is the formula? Divided by n. What is n? The total number of observations. We know that the total number of observations here are 5. Minus summation of xi upon n square, c, minus mean square. The formula for variance is mean. And what is mean? Summation of xi upon n. The value of mean is 13. So minus 13 square. So we have minus 13 square. Now it is given that the value of this variance actually belongs to n. Okay, the number of values for a belongs to n. So we can write that this variance basically belongs to n. Now we have to simply solve it. 9 plus 49 plus 144 plus a square plus 43 minus a square. When we take the LCM will be 5, right? And the numerator for the first part will be same. Minus 5 into 13 square. What is 13 square? 13 square is 169, right? 13 square means 13 into 13. So it is 169. 169 into 5 is 845. So 845 and it belongs to n, right? So now we have to add these values. 9 plus 49, right? 9 plus 49 plus 144. What is 9 plus 49 plus 144? It is 202 plus a square plus 43 minus a square minus 845 divided by 5. It belongs to n. What is n here? N is the set of natural numbers. So let us do one thing. Let the number be n. All right. So this will be equal to 202 plus a square plus 43 minus a square minus 845 divided by 5 is equal to n. We are assuming the number as n. We are assuming a natural number as n. So when we cross multiply here, we will have 202 plus a square plus 43 minus a square minus 845 is equal to 5 into n, 5n. Now when we further simplify this value, it will be equal to 2a square minus a plus 1 is equal to 5n. When we take 5n on the left hand side, it will be 2a square minus a plus 1 minus 5n is equal to 0. Okay, so this is the equation which consists of a natural number n and which consists of a constant which is a. All right. This is the equation which we have formed by using the formula for variance. Okay. And we know that this equation must have solutions as natural numbers. So how to find the roots or the solutions for this equation? We can do one thing. We can find the value of discriminant. Discriminant is denoted by d and it is always equals to b square minus 4ac. Here in this equation, when we compare the values, what is the value of a? A is the coefficient of a square. So a is 2. B is the coefficient of a. What is the coefficient of a here? Minus 1. So the value of b is minus 1. And the remaining constant terms are c. So what are the remaining constant terms? 1 minus 5n. So c is equal to 1 minus 5n. Let us put all this value in this formula for discriminant. So d will be equal to b square. What is b? Minus 1. So minus 1 square minus 4 into a into c. What is a? 2 into c. C is 1 minus 5n. Now let us solve it. D will be equal to minus 1 square. Minus 1 into minus 1 is plus 1. Minus 4 into 2 is minus 8. Multiplied by 1 minus 5n. So it will be 1 minus 8 into 1 is 8. Minus 8 into minus 5n. Plus 40n. 8 5s are 40. And we have n. So minus 8 into minus 5n is plus 40n. So it will be equal to minus 7 plus 40n. Right? 1 minus 8 is minus 7. So the value of discriminant is 40n minus 7. Now, this value should have the number for n, which will have a unit place 3. See, this value of discriminant is 40n minus 7, and this value will always have 3 at the unit place, right? So, do you know any number whose unit place in 3 and it is a perfect square? There is no such number, means no such number actually exists. Any number with unit place 3 is not a perfect square. Okay. We have not seen any number whose unit place is 3 and it is a perfect square. So we can say that it can't be a perfect square. It means that here D can't be a perfect square. Okay. Whatever value we keep here in place of n, then the answer will always have a digit whose unit place will be 3, right? So D can't be a perfect square. And if D can't be a perfect square, so we cannot find any integral roots for the equation, which is 2a square minus a plus 1 minus 5n is equal to 0, right? It means that a can't be an integer. Okay, the value of a will not be any integer. It means that we cannot find any integral roots of this equations. I hope the concept is clear to you. Here the value of the determinant is 40n minus 7. Here we have to keep a value of n. Okay, and whenever we keep a value of n, we always get a digit whose unit place will be 3, right? So consider n is equal to 1. So 40 into 1 is 40. 40 minus 7 is 33. You can see that the unit digit is 3. And 33 is not a perfect square. No number with a unit digit 3 is a perfect square. It means that D can't be a perfect square. If D can't be a perfect square, then A can't be an integer. And we cannot get any integral roots or solutions of the equation. So for this question, the correct option will be that A can't be an integer, right? So here the number of values for A which belongs to n. See, if A belongs to n, it means that A is a natural number, but we have come to a conclusion that A can't be an integer. So the number of values for A which are natural numbers are actually 0 because there are no values for A which are integers. So for this question, the correct option is option A here. Next question is, from the base of a pole of height 20 meter, the angle of elevation of the top of a tower is 60 degree. The pole subtends an angle 30 degree at the top of the tower. Then the height of the tower is. It is a very easy question. This question comes from 9th class and 10th class. We have studied about angle of elevation and angle of depression, right? So this is a question that comes from that portion. Firstly, let us understand the question. We have a pole whose height is 20 meter. And we have a tower. We have to find the height of the tower. So let us consider AB as the pole. This is A and B. What is the height of the pole here? It is 20 meter. Let us consider CD as the tower. We have to find the height of the tower, right? So let the height of the tower be H. So this is H, which is the height of the tower. Two different angles are given here, which is the angle of elevation of the top of tower is 60 degree. And it is from the base. See, from the base of a pole. What is base of a pole? This is the base of a pole. An angle is made on the top of the tower. First, let us connect the base of the pole to the top of the tower, right? It is making an angle of 60 degree. This is the angle of elevation. One more angle is given, which is pole subtends an angle 30 degree at the top of the tower. Okay. So from top of the pole, an angle is made to the top of the tower, which is 30 degree. So let us do one thing. Let us make a horizontal line here. And now let us join BD. What is BD? B is the top of the pole and D is the top of the tower. An angle is made here, which is 30 degree. Let us name this point as M. Since we have drawn a horizontal line here, then AB will be equal to CM. AB is 20, so CM will be also 20 meter. Now, if we want the distance of DM, okay, so what will be DM? We know the whole value is H. What is the whole value? The value of CD. CD is the height of the tower. CD is H here. And if from CD we have the value of CM, then we can find DM. What will be DM? It will be H minus 20, right? See, consider this line as CD. This is C and this is D. We have a point here which is M. If we know the whole value is H, right? And if we know CM, CM is 20. So the remaining value will be what? Total value minus CM. What is the total value here? H. H minus CM. H minus 20. So this value DM will be what? H minus 20. Now you can see that we have two different triangles. One triangle is DCA and another triangle is DMB. Both the triangles have the angles 30 degree and 60 degree. So let us consider first triangle. What is the first triangle? Triangle DCA. We have 60 degrees. So if in triangle DCA we take tan theta, means tan 60. Then tan 60 degree will be equal to what? It will be equal to H upon Y. Okay. Let us consider this as Y. So if AC is Y, then BM will be also Y. Okay. We have considered the distance from the height to the tower as Y, right? So what is tan theta? Tan theta is perpendicular upon base. You can see that in triangle DCA, perpendicular is H and base is Y. So we have tan 60 is equal to H upon Y. Now what is the value of tan 60 degree? Tan 60 degree is equal to root 3. Okay, so root 3 is equal to H upon Y, right? So from here we have Y root 3 is equal to H and Y will be equal to H upon root 3. Consider it as equation 1. Now let us focus on the other triangle. What is the other triangle? DMB. So in triangle DMB, if we take tan theta, you can see that in triangle DMB, what is theta? 30 degree, right? So tan 30 degree will be equal to perpendicular upon base. What is the perpendicular for triangle DMB? The perpendicular is H minus 20. Okay, this is the perpendicular upon base. What is base? Y. So tan 30 degree will be equal to H minus 20 upon Y. Now what is the value of tan 30 degree? Tan 30 degree is 1 upon root 3. So 1 upon root 3 will be equal to H minus 20 upon Y, right? So what will be the value of H minus 20? H minus 20 will be Y upon root 3, right? This Y will be multiplied here. So we have H minus 20 is equal to Y upon root 3. Okay. But we have the value of Y. What is the value of Y? H upon root 3. So let us do one thing. Let us substitute the value of Y here. So it will be H upon root 3 into root 3. So this will be equal to H upon 3. Root 3 into root 3 is 3. And H upon 3 is actually equal to H minus 20, right? So H minus 20 is equal to H upon 3. Now let us cross multiply here. So 3H minus 60 is equal to H. 3H minus H will be equal to 60, right? What is 3H minus H? 2H. 2H is equal to 60. If 2H is equal to 60, then H will be equal to 60 by 2, which is equal to 30. So H is equal to 30 meters. What is H? H is the height of the tower and this is the value that we have to calculate, right? So for this question, the correct answer is option D, which is 30. See, it is a very, very simple question. You just have to take two triangles, right? And you have to take tan theta in both the triangles. Then from that, you will form two different equations. And by using both the equations, you can easily find the value of H, which is the height of the tower. So for this question, the correct option is option D here. Next question is negation of the Boolean statement P or Q, then negation of R or P is equivalent to. We have to find the negation of this statement. So firstly, let us solve this statement. What is the given statement? It is P or Q, then negation of R or P. To solve this statement, we need to understand that there is a basic concept and the concept is if we have P then Q, then this form is always equivalent to negation of P or Q. You can see that the given expression is in the same form. If P, then Q. This is P and this is Q. So this expression will be equivalent of negation of P or Q. Okay. So let us apply the formula here. This is if P, then Q. Then it will be equal to what? Negation of P. What is P here? P is this term. So negation of P or Q or Q. You can see the formula is negation of P or Q. Now what is the value of Q? This is the value of Q. So we have Q negation of R or P, right? Now this is the simplified statement, but remember that we have to find the negation of this statement. So taking negation here, we have negation of P or Q or negation of R or P. Now, when we apply negation here, negation of P or Q will be P or Q. Okay, this negation and negation will be cancelled for these two terms. So we have P or Q. Now, due to this negation, this or will be changed to and. Then we have negation of R or P, right? This is equal to P or Q and negation of R will be R, right? Again, due to negation, this or will be changed to and negation of P will be negation of P. Now, this is the form. Now, we have P or Q and R and negation of P. We have to apply distributive law here. So, applying distributive law, what is distributive law? We have to take P or Q with R, then we have to take P or Q with negation of P. Okay. So firstly, we will take P or Q and R. All right. In middle also there is and. So this is the first term. Now we have to take P or Q with negation of P. So P or Q and negation of P. All right. You can see that both the signs are and. So first we have to take P or Q and with R, and then we have to take P or Q and with negation of P, right? So we have applied the distributive law here. So this will be P or Q and R, all right? Then we have and. Now this expression will be actually equal to negation of P. Because it is P or Q and negation of P, this expression is equal to negation of P. Let us understand this by using a Venn diagram, all right? So let us consider P, Q and R. This is P, this is Q, and this is R. Okay. What is the statement? P or Q. Okay. It means firstly we have to take this whole region of P and this whole region of Q, right? Then and R. Okay. Means we have to take R2. And negation of P means we have to exclude this P part. Okay. Negation of P means we do not want to take P. So what will be the remaining region? If we do not want to include P, the remaining region will be the common region between Q and R. What is the common region between Q and R? This is the common region between Q and R. So this will be the Venn diagram for this given condition. All right. First we have taken whole P and whole Q. Then we have taken R. But again by this condition and negation of P, it means we have to remove this P. So what is the common part for Q and R? This is the common part for Q and R, right? So this will be the Venn diagram for the given condition. Now let us check for all the options. Okay. What is the first option? P or and negation of Q and R. Okay. Remember that our condition is we have to just apply negation of P, right? Means we do not want to include P. We want to include Q and R, right? So first option is including P. It means that it is absolutely wrong. Okay. For first option, there is negation of Q, but we have to include Q and R, right? So if we draw the Venn diagram for the first option, right? What is the first option? First option is P and negation of Q and R. So if we draw the Venn diagram, this is P, this is Q, and this is R. Negation of Q means we do not want to take Q. We have to take the common portion for P and R. This is P, Q and R. What is the common portion for P and R? This is the common portion for P and R. But it is not matching with the Venn diagram for our condition. We should get this particular Venn diagram, right? It means that first option is wrong. Now let us check for second option. The second option is negation of P and negation of Q, right? This is the second option and R. So and R. So for this, we do not want to take P and Q. We only want to take R. So what will be the Venn diagram? If we do not want to take P and Q, we only want to take the region for R. This is P, Q and R. We do not want to take P and Q. So the remaining portion of R that does not contain P and Q is this portion, right? We only want to include R. This is also not the Venn diagram that we want. So second option is also not correct. Now let us have a look towards the third option. What is the third option? Negation of P and Q and R. All right. So negation of P and Q and R. It means that we do not want to include P, but we want to include Q and R. So the Venn diagram will be in this way. This is P, Q and R. We do not want to include P because there is negation of P. Negation means we do not want to include that part. But you can see that there is no negation in Q and R. It means that we want the common area for Q and R. What is the common area for Q and R? This is the common area for Q and R. Okay. So this is the same Venn diagram that is representing the condition which we have solved. Okay. You can see that this is the Venn diagram we want and it is matching with the option C. So for this question, the correct option is option C here, right? So the correct option is C. I hope you are clear with this question. The main concept that we have used here is if P then Q, if we have this form, then it will be always equivalent to negation of P or Q. And remember that first term is P and the second term is Q. Okay, because it is in the same form if P then Q. So we have used this basic concept to solve this question and the correct option is option C here. Next question is, let n greater than or equal to 5 be an integer if 9 power n minus 8n minus 1 is equal to 64 into alpha and 6 power n minus 5n minus 1 is equal to 25 into beta, then alpha minus beta is equal to. We have two different equations which is in the form of alpha and beta. And by using this equation, we have to find the value for alpha and beta. Then only we can calculate alpha minus beta, right? And whenever we get this kind of expressions, we need to understand one thing that this is a equation that comes from binomial expansion. The given equations are 9 power n minus 8n minus 1 is equal to 64 into alpha and 6 power n minus 5n minus 1 is equal to 25 into beta. We can actually change these equations in a binomial expansion. How to change it? You can see here the first term is 9 power n. And we know that there is a form of binomial expansion which is 1 plus x power n. If we have a form of binomial expansion which is 1 plus x whole power n, then it is equals to nc0 plus nc1 into x plus nc2 into x square plus so on up to ncn x power n. This is the basic formula that we have to use for this equation. Now, let us convert these equations in the form of 1 plus x power n. You can see that the first term is 9 power n. 9 power n can be written as 1 plus 8 power n because 1 plus 8 is 9 only. So we can write 9 power n as 1 plus 8 power n. And similarly, 6 power n can be written as 1 plus 5 power n. So let us substitute the values here. If we substitute the values here, we have 1 plus 8 power n minus 8n minus 1 is equal to 64 alpha. If we want the value of alpha, then alpha will be equal to 1 plus 8 power n minus 8n minus 1 divided by 64. This 64 is in multiplication with alpha. So when it will go to the other side, it will be divided, right? So now we have the value of alpha. Similarly, if we substitute 6 power n is equal to 1 plus 5 power n in this equation, then we get 1 plus 5 power n minus 5n minus 1 is equal to 25 beta. Now from this equation, if we want the value of beta, then beta will be actually equals to 1 plus 5 whole power n minus 5n minus 1 divided by 25. Now we have the value of alpha and beta. But we have to use the formula for 1 plus x power n. Okay. So let us first simplify alpha. What is alpha? 1 plus 8 power n. Here, if we compare it with the formula, the first term is 1, the value of x is 8, and the power is n. So this formula is equal to nc0. nc0 plus nc1 into x. What is x? X is 8. Plus nc2 into 8 square. What is 8 square? 64. But let us write it 8 square, right? Then so on up to ncn x power n, right? So this is the basic form for this expression. Now you have to remember two basic things, that the value of nc0 is always equals to 1 and the value of nc1 is always equals to n, right? So here the remaining terms are minus 8n minus 1. So let us write them, minus 8n minus 1 and whole divided by 64, right? Now alpha will be equals to what? nc0 is 1, right? Then nc1 into 8. What is the value of nc1? nc1 is always equals to n. So we have 1 plus n into 8 is 8n plus nc2 into 8 square. So nc2 into 8 square. What is 8 square? 64 plus so on up to ncn x power n. And then at last we have minus 8n minus 1 divided by 64, right? This plus 1 and minus 1 will be cancelled. Plus 8n and minus 8n will be cancelled. So we have alpha is equals to nc2 into 64 plus nc3 into 8 power 3. See, this is a series, okay? It will go up to ncn x power n, means 8 power n, right? So this is the basic form, right? Now, here we have to notice one thing, that this 64 will be cancelled with the denominator, okay? This 64 is the minimum power of 8 that we can take common from this expression, right? See, it is starting with 8 square, then 8 cube, then so on up to 8 power n. So the minimum square of 8 that we can take common from here is 8 square, right? So let us take 8 square common. So when we take 8 square common, then the remaining terms here are nc2, right? Because 8 square is 64, we have taken 64 common, plus nc3 into 8, we have taken 8 square common, so here the remaining term will be 8, plus so on up to nc n 8 power n, right? And it will be divided by 64. Now what is 8 square? 8 square is 64. So 8 square and 64 will be cancelled. So now the remaining terms for alpha will be what? nc2 plus nc3 into 8 plus nc4 into 8 square and so on. Okay, this series will go up to ncn. Now we have the second equation, which is in the form of beta. So let us simplify this equation. Let us write it again. Beta will be equal to 1 plus 5 power n minus 5n minus 1 divided by 25. Again, if we use the formula for 1 plus x power n, here x is 5. So beta will be equals to nc0 plus nc1 into x. What is x? 5. Plus nc2 into x square means 5 square plus nc3 into x cube. So 5 cube plus so on up to ncn into 5 power n. And it will be again divided by 25. We know that nc0 is 1. So the first term will be 1. nc1 is n. Okay, the value of nc1 is n. So n into 5 is 5n. And here at last, we have minus 5n minus 1. Okay. See, we have expanded this term. Okay, so the expansion is up to this part. At last, we have two more terms, which is minus 5n minus 1, right? Now, nc0 is 1, nc1 is n, so n into 5 is 5n, plus nc2 into 5 square, plus nc3 into 5 cube, plus so on up to ncn 5 power n, minus 5n minus 1, whole divided by 25. Here again, plus 1 and minus 1 will be cancelled. Plus 5n and minus 5n will be cancelled. So what are the remaining terms? Beta is equal to nc2 into 5 square plus NC3 into 5 cube plus so on up to NCN into 5 power n divided by 25. Now you can see that in the numerator, the minimum value that we can take common is 5 square. Okay. So let us take 5 square common. When we take 5 square common, the remaining terms here will be NC2 plus the remaining terms here will be NC3 into 5 because out of 5 cube, we have taken 5 square common. So remaining will be 5 plus so on up to NCN 5 power n minus 2. Why n minus 2? Because we have taken 5 power 2 common, right? So this will be divided by what? 25. Now again 5 square is 25. So 5 square and 5 square will be cancelled. Okay. So now what are the remaining terms? The remaining terms for beta is NC2 plus NC3 into 5 plus so on up to NCN into 5 power n minus 2. Okay. We have the value of alpha and we have the value of beta, right? Since we have the value of alpha and beta, we can find alpha minus beta, right? Let us first write alpha. What is alpha? Alpha is NC2 plus NC3 into 8 plus NC4 into 8 square plus so on, right? So alpha minus beta. So let us do alpha minus beta. What is alpha? NC2 plus NC3 into 8 plus NC4 into 8 square plus so on, right? Now we have to subtract beta. So minus NC2 minus NC3 into 5 minus so on up to what? NCN into 5 power n minus 2. And if we notice here, for alpha also the last term will be what? NCN into 8 power n minus 2. Okay, because we have taken 8 square common. When we have taken this 8 square common, the last term will be NCN into 8 power n minus 2, right? Don't forget this part. The last term is a must. So here you can see that plus NC2 minus NC2 will be cancelled. Okay. Now NC3 into 8 and minus NC3 into 5. NC3 is common. And what is the remaining numbers? 8 minus 5 plus. Again, for the next term, what will be common? NC4 will be common. Okay. Here we will have NC4 into 5 power 2, right? If we talk about the next term here, since it is a series, so we will have NC4 into 5 power 2. So NC4 will be common. So the remaining terms will be what? 8 square minus 5 square. It will go up to the last term. What is the last term? Last term will be NCN. Okay, NCN 8 power n minus 2 and NCN 5 power n minus 2. So again, NCN is common. What are the remaining terms? 8 power n minus 2 minus 5 power n minus 2. So this is the exact value of alpha minus beta. Now let us check the options. If we check the options, the correct option here is option C, which is NC3 into 8 minus 5 plus NC4 into 8 square minus 5 square. It is going up to NCN into 8 power n minus 2 minus 5 power n minus 2. So for this question, the correct option is option C here. I hope you are clear with this question. The main formula that we have to use here is the formula for 1 plus x power m.